Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
Hey folks, welcome to my course, Linux Red Hat Certified System Administrator course. In short, RHCSA. If you actually have never touched Linux, and this is your first time trying Linux, then I'll tell you right now, stop, because this is not the course for you. You should be taking my other best-selling course, which is Complete Linux Training Course to get your dream IT job. Now, for those of you who have some level of Linux or intermediate level of Linux skills and you want to become Red Hat certified, then you have come to the right place because this is the course for you. My name is Imran Afzal and I have over 2 decades of experience in information technology. I have been teaching for a while and I have some of the best-selling courses out there. I have completed my bachelor's degree from Baruch College in Computer Information System, and I have done my MBA from New York Institute of Technology. Now, regarding RHCSA, as per Red Hat recommendation, they are asking you to take Red Hat 124 and Red Hat 134. These are the 2 classes that you should take in order to take the RHCSA exam. Now, each of these classes are 5-day class. So you would have to spend 5 days in one class and 5 days in another class. And RH 124 cost $3,600 US. RH 134 cost $4,500 US. As per today when I'm recording this video. It could go up as the time passes. Now, what I have done is I have taken the material, the outline of both of those classes, and I have included in this class. So you don't have to spend over $8,000 to go and get Red Hat certified. All you need is to take this class, my class, because I have divided this class into 2 different sections. One is RH 124 and one is RH 134. So, are you ready to become Red Hat Certified System Administrator?
Okay, folks, let's talk about the exam details. What is the objective of this exam? It is to become a certified Red Hat system administrator so you could install, configure, manage, and troubleshoot Red Hat Linux servers efficiently. Now, the name of this RHCSA exam is EX200 and its duration is 3 hours. It used to be 2.5 hours, but now they have extended the time. At this time, when I'm recording this video, it is 3 hours. It could go more or less. It depends, but you have to check on their website to see the duration. Then the location, it depends where you are, where you live. It could be either virtual or at a Red Hat location. What is the cost? Once again, it depends on where you are, which country you live in. In USA, it costs $400 to take the exam. Now, what's the validity of this exam? How long it will remain active? It will be valid for 3 years from the time you pass the exam. The format of the exam, it's completely hands-on practical exam. There will be no internet access. You are not allowed to bring any kind of documentation or handouts for that matter. However, you could use the man commands within the Linux environment to get access to the commands and its documentation. You will be provided 2 Linux servers to log in back and forth and perform the required task. Then the results. Once you take the exam, it usually takes within 3 business days until you get your certification or whether it's going to be pass or fail. Hopefully you do pass. Benefits. It adds value to your profile and helps you with your job search. It gives you significant technical improvements in managing your Linux servers, and it will give you a big boost in your career growth if you wanted to level up your career. These are the few exam details. If I have missed anything, I would recommend you that you go on Red Hat website and you could get all the information that you're looking for right on their website about this exam. Hello and welcome. In this video, we are going to talk about the prerequisite for taking the RHCSA exam and what is included in this course that I'm going to teach you. It is strongly recommended by Red Hat that you take the following classes before taking the RHCSA exam. And those classes are RH or Red Hat 124 and RH 134. RH 124 is a 5 days class and it costs 3,600 US dollars. RH 134 is also 5 days class and it costs 4,500 US dollars. And this is the cost as of right now when I'm recording this video. It could go up or come down, it could change, but please check the Red Hat website to get the accurate pricing information. Now, here is the good news for you. And that good news is I have covered the material of both of these classes in this course, and I have followed the same format, the same structure that Red Hat outlined on their website. Okay, so the very first thing we will do is we will set up our lab. We'll download and install Oracle VirtualBox or VMware Workstation Player. Either one, you pick, you decide whichever your favorite virtualization software that you could install on your machine. You could install it on your Windows or Mac machine. Then we will go ahead and create the virtual machine and then we will install Red Hat Linux version 8. Then we get on to the next section and we will cover everything that is included in RH 124 as per the Red Hat website. And these are the list of topics exactly from Red Hat that they are telling us to actually cover for your RACS exam. So, for example, we'll get started with Red Hat, access the command line, manage files, get help, create and view files, manage users, control access to files, monitor and managing Linux process, SSH, checking logs, networking, transfer files, update software, and so much more. Then on 134, we will cover the advanced topics that are or that you need to know for our HCSA exam, and that is improve command line productivity. That is all about bash shell scripting. Scheduling future tasks using cron or at, tune system performance, ACL, SC Linux security, managing basic storage or logical volumes. Also, advanced storage features with Stratus. Access network attached storage that covers both NFS and Samba. Control the boot process, manage network security, install Red Hat Enterprise Linux, and run containers. This list I got exactly from the Red Hat website. So if I go to my browser and I type RHCSA, and I will go right here where it says Red Hat Certified System Administrator, you will go to training. And right here, these are the two classes that Red Hat recommending that you take before taking the exam. So RH124 outline, you could actually view everything that I have just covered in my PowerPoint slide with exact same topics that they are covering in this class. Similarly, if you go to R34 and then go to outline tab, and you will notice everything, all the topics that they are or they will be covering during this class, I am covering in this course. So, are you ready to take this journey with me and become a Red Hat certified system administrator? Hey folks, welcome to the section 2, and this section 2 consists of everything we have to do with the lab setup. Of course, we need our lab where we could install our operating system and practice on it. So, how are we going to set up our lab? Well, we have our computer in your case or in my case, I have a laptop or a desktop, and on that desktop, I am running Windows 10 operating system. And then I'm going to install a virtualization software. Virtualization software allows me to run multiple operating system on a single hardware. And the software that I'm going to show you is the download installation of VMware Player as well as Oracle VirtualBox. But for this entire course, my focus is going to be Oracle VirtualBox. That's the software I will be using throughout the course. Now, on top of that virtualization software, I'll create a virtual machine, and that virtual machine will have the operating system of Red Hat. So let's go right into it. And the very first thing we'll do is install Oracle VirtualBox. Hey everyone and welcome back. In this video, we are going to create a virtual machine so we could run our operating system. All right, so we have our main physical machine running Windows 10 and we have installed the virtualization software. Softwares are Player and Oracle VirtualBox. Now it's time to create a virtual machine and we will use Oracle VirtualBox to create a virtual machine with the following specification. It will have 20 gig of disk space, 1 gig of memory, which is the RAM, and one virtual CPU. All right, so let's go start our Oracle VirtualBox. Okay, go ahead and click new. You click create a new virtual machine from here or machine from here. Give it a name, my first Linux VM. This is the name I picked. You could pick anything you want. It's just the name of the virtual machine. So when you type in VM, you notice automatically it gives you the type of Linux. It automatically gives you the version, which is 64-bit. Click next. The size of your memory is by default is 1 gig. So 1024 meg when you divide it by 1024, then you will get 1 gig. Click next. Recommended size of the disk is 8 gig. Create a virtual hard disk now. So we will change that in the next screens. Click create. Hard disk file type, leave it default. And here we will change it from 8 to 20. Click create. Okay, so our virtual machine has been built and created. I want you to go to setting, click network, and you see right here it says attached to NAT. Pick, click on scroll down and pick bridged adapter. This will allow you to connect to the internet. Go ahead and click OK. All right, so your now virtual machine is ready, and the next step is to download and attach the ISO image of Linux to this virtual machine and go through the installation. I'll see you in the next lecture. Hey folks, in this video we are going to download and install Oracle VirtualBox. What we will learn is how to check system resources on our computer to make sure we could actually install and run the Oracle VirtualBox software on our computer. And then the second thing, once we confirm that, then we'll go ahead and download, install the Oracle VirtualBox software on our main computer. So first thing first, let's check the system resources. I'm using Windows 10, so I'm going to hit Win key on my computer and it will open up the search and programs. Simply type PC and you will see it will come up as this PC if you're running Windows 10. If you're running any older version, you're probably going to see My PC. But it doesn't matter, just simply right click and go to properties. Here you will see I'm using Windows 10 Pro, the processor and memory. One of the basic things that you have to make sure is if your RAM is anything less than 4 gig, then you have to upgrade your computer so you could go through with me on the course. And also make sure your system type is 64-bit. All right, so we do have enough resources in terms of CPU and RAM and system type. Now, next thing we need to check is how much disk space I have. Again, hit the Win key, type PC, and this time instead of right clicking, just simply do left click and it will open up this window. In this window, you have to go to the C drive On my C drive, I have total of 475 gig of disk space, out of which 259 gig is free. Beautiful. So I have enough resources to create multiple virtual machines within um, certain limitations. Just make sure you're not creating a virtual machine that exceeds this number. All right, let's move on. Now it's time to download the Oracle VirtualBox. All right, so for that, we'll go to um, www.virtualbox.org. And here you will get this link, download VirtualBox 6.1. Depending on when you are watching this lecture, it might be a newer version, but it doesn't matter if it's a newer version, older version. It's the what matters is that you're installing virtualization software. So go ahead and click on it. All right, it will tell you your base operating system. So we have already checked that my computer has Windows. So I'm going to go with the Windows host and save file. Once it's saved, depending on where it has saved on your computer, you could click from here or you could click from your desktop if it saves it to your desktop. The easiest way is go here and click on it and it will start running that software installation. So this is a wizard. It's telling you that it's starting. Welcome. Click next. Leave everything default. Next. Create start menu entries. Create a shortcut on desktop. Create a shortcut quick launch bar. I like it all except this one. So I'm going to uncheck it. Again, it all depends on your preference. Click next. Proceed with installation. Yes. By the way, let's go back um, right here where it says warning network interfaces. It will reset your network interface of your main computer. So if you're running any production application or anything that might interrupt your workflow, I would highly recommend stop it. Then you come back to it and then install it. So go ahead and click yes, install. All right, depending on the speed of your computer or how fast your computer is, it could take anywhere from 30 seconds to 2 minutes. Mine finished really fast and it says Oracle Virtual Machine VirtualBox installation is complete. And click finish. Okay, so now it's gonna open up my VirtualBox right here. Go down and you will see this is how the Oracle VirtualBox looks like. And here we are going to create new virtual machines in the later lecture. Hey folks, and welcome back. In this video we are going to download and install Oracle VirtualBox software. So if you go through step by step, the very first step is, of course, we have to open up your internet browser and visit www.virtualbox.org. Then the next step is go to its download page and find where is the download page on the navigation bar, and then you will see the most recent software that you could download. All right, once the software is downloaded, the next step is, of course, to execute it and go through the installation and configuration procedure of the software. Okay, very simple and straightforward. So let's start up our browser. Now, of course, pick the browser of your choice. I'm gonna go with Google Chrome. So I'll go type Chrome, and here I will type it in www.oracle, sorry, virtualbox.org, and it will bring me to this page. Let me move this up. All right, this page will give you the welcome to virtualbox.org, some information about it. I want you to go to the navigation pane and right here click on downloads. Okay, when you are on the download page, right here it says VirtualBox 7.0.10 platform packages. Now, depending when you are watching this video, the version might have changed. So it doesn't really matter if the version is changed to a higher version. All you have to do is download this virtual software, the most recent one. Okay, then which platform? Are you using Windows machine where you're going to be downloading this? Then yes, click on this one. Are you using Mac? Are you using other Linux distribution or Solaris distribution? So for us, in our case, we have a Windows machine, so we'll click on Windows host. Okay. Once you click on it, it will start the download, and of course, the download process is very fast. It has already downloaded, see right here, and it downloads to my desktop. Okay, so now where is my desktop? So let's go to my desktop. All right, right here on my desktop, you see this is the executable file that it has downloaded. Now go ahead and double click on it so it could start the installation procedure. All right, the first thing is, do you want to allow this app to make changes to your device? Yes, of course, because we want to go through the installation. Okay, next step is welcome to the Oracle VM VirtualBox version setup wizard. This setup wizard will install Oracle VM and so on. Click next. Okay, select the way you want features to be installed. I want you to leave everything default. Now, you could customize it depending on your requirement, but again, since we are doing it for the first time, and this is for our lab, we're gonna leave everything as is and just simply click on next. Warning, network interfaces. Installing the Oracle VM VirtualBox in networking feature will reset your network connection and temporarily disconnect you from the internet. Proceed with installation now. Now, before you click yes, make sure you're not running any type of important downloads or program in the background that will interrupt the network connectivity. If it is, go stop it and then come back and then do click yes. But of course, again, this is a lab. We know we are not running anything, so go ahead and click yes. Missing dependencies, Python core. If you're getting these messages, that's fine. It will install these dependencies as well, so click yes. All right, begin installation, ready to install? Yes, go ahead and click yes or install. Okay, Oracle VM VirtualBox 7010. Please wait while the setup wizard installs Oracle VM VirtualBox. This may take some time. Of course, for me, it's took literally like 15 seconds. All right, Oracle VM VirtualBox installation is complete. Click Finish. Start Oracle VirtualBox. If it's checked, then it will start the program right away. So click Finish, and it will start the Oracle VirtualBox application right now. All right, let's see if it is running on our tray or task manager. Yes, it is. See right here, it is running. Okay, so here it is Oracle VM VirtualBox. This is how the Oracle VirtualBox after installation, the portal will look like. Now, this portal allows you to create a new virtual machines, add existing ones if you already have it, import it, export it, and all these features you could go through one by one and understand. But of course, our main focus of this course is not to learn the virtualization software, but to actually learn Linux. So I'm going to leave that little piece of learning with you. If you wanted to explore more, go through it and learn it. But for now, we'll stop here and we'll go to the next video. In the next video, we will go ahead and create a new virtual machine so that virtual machine can have Linux operating system on it for our lab environment so we could practice Linux commands on it. Hey everyone, let's get the fun begin. In this video, we are going to download and install Red Hat Linux version 8. So what we're going to do is on our PC, which is running Windows 10, we have already installed the virtualization software and we are using Oracle VirtualBox. We created our virtual machine on it. Now it's time to install Red Hat Linux on it. Okay, so we'll go to our Firefox browser and I want you to go to access.redhat.com. Once you come to this page, you will see the option of downloads and you will see right here it says Red Hat Enterprise Linux 8. Click on it. You will have to put in your username and password. If you never had an account with Red Hat, you could create a new one. So go ahead and put in the username. I already have my username created earlier. Click next. I'll put in my password. Okay, it's checking my authentication. Done. Coming down right here, it says Red Hat Enterprise Linux 8.4 boot ISO. This is what we need. The latest version right now is 8.4. It doesn't really matter if you're doing 8.2, 8.4, 8.6. What matters is that you will be taking the exam that is based on version 8. So click download now and it will give you the option to save the file. I have already saved the file earlier to save some time. So I'm going to go ahead and click cancel. Now I will go to my VirtualBox one more time. And right here you see my VirtualBox. One second, I have two VirtualBox open, so I'm going to close one. So I'll go back to my VirtualBox. Now go ahead and select my first Linux VM and click start. Okay, you have to click on this little folder icon. If you have never attached the image before, you could attach it. I have already attached it before, so you will see it is already there. For those who are doing it for the first time, you have to click add and it will ask you where is your ISO image. So you pick the ISO image and click open. And then once it's open, then you could click on choose. Now go ahead and click start. Okay, pick the first option by moving your cursor up and it says install Red Hat Enterprise Linux 8. Hit enter. Okay, language and region. I have I'm picking English in the United States. Click continue. Okay, so we have to provide some information where you see these red indication. So first we should do is connect to Red Hat, but before we connect, we need to make sure we have internet connection. So for that, we have to go to network and host name. So click here where it says not connected. Turn on the Ethernet adapter and come here and type in my first Linux VM or OS, whatever the name that you want, that will be your operating system host name. Click apply. Current host name has changed and now go click on done. It will take you back. Now it's time to go to connect to Red Hat and put in the username, the same username as you used to create your account on Red Hat. You can uncheck the insight, click register. Okay, so the system has been properly subscribed. Its start date is the day that you are installing till a year from now. Click done. Installation destination. Where are you installing? You're installing on your 20 gig disk. Perfect. Click done. Okay. Software selection. Server with GUI. Leave it default. Click done. User setting. Root password. Select the root password. Please make sure you write it down, the root password. Do not forget that because if you do, it's very hard to recover. All right, so I picked the weak password. That's why it's telling me it's a dictionary base. I have to press twice to accept it. So done once, done twice. All right, so you see all the red indication is gone. So the last thing I wanted to do is create a user. So let's create our regular user. Put in a name, full name, Imran Afzal in my case. Make this user administrator, leave it as is. Require a password for this account. Yes. Pick any password that you like. Again, you have to click done twice if you are choosing a weak password. All right, I think we're pretty much done. As soon as everything is done, it will give you the option to click on begin installation. Preparing, configuring, and it is picking all the installation that is needed. Now, this will take um, anywhere from 5 minutes to 30 minutes. It depends again from on your computer speed. So what I will do is I'll go ahead and fast forward from this point. So installation for the Red Hat has been completed. You could go ahead and reboot your system. On this screen, click on license information and click accept the license agreement. Done. All installed products are covered by valid entitlements. It's good. Click finish configuration. I'm logging in. Click on your name. Enter the password. All right, so this is the screen that you will get when you log in. Now you could change the look. So we got the welcome screen. Click next. Typing English by default. Click next. Location services, you could turn it off. Next. Connect to your online accounts. You can skip that and start using Red Hat. All right. So this is how the Red Hat GUI looks like. You could change it any way you want. Let's cancel it. You could change it any way you want. You could make the background white. You could make the terminal look white as well. So right now, if you go to activities and you go to this terminal thing, you will see the terminal is showing up black. So you could change that to white as well, the font to black, which whatever the setting that you want, it really doesn't matter because this is not what you will be tested on during your certification exam. So anyway, going forward, you don't have to focus on how it looks, the color. If I have a different color, you have a different color. What you need to focus is the command that we will use during this entire course. I'll see you in the next lecture. Hello again. In this video, we are going to download and install VMware Workstation Player. Once again, the VMware Workstation Player is a virtualization software just like Oracle VirtualBox. And I am going through the download and install of Workstation Player for those who prefer to use the VMware Workstation. By the way, as I said before, I will be using Oracle VirtualBox for this entire course. All right, without further ado, let's go ahead and start up our browser. I have my Firefox already open and I am on Google and now simply type download VMware Workstation Player. All right, and then you're going to get the first link most likely, download VMware Workstation Player. Click on it, download it, come down and you see try Workstation 16 Player for Windows. If you are watching this video a year from now, maybe a few months from now, you might see that the version might have changed or went up. So it doesn't really matter. What matters is we are downloading and installing virtualization software. Go ahead and click download now. Save file. See up here, it's downloading. Download has completed. You could click on it and run the program right from here. All right, Workstation 16 player wizard is starting. It could take anywhere again from 30 seconds to 2 to 5 minutes depending on your software, your computer system speed. All right, click next. Accept license next. Enhanced keyboard driver. If you want that, your computer will be rebooted. I don't want it right now. Add VMware Workstation console tools into the path. That's fine. Leave it default. Click next. Check for updates. I don't want that. And join VMware customer experience. I don't want that right now. Click next. Create a shortcut on desktop. Shortcut menu on programs. I just don't want on the desktops. I could leave it on start menu programs folder. Click next and install. Okay, completed the VMware Workstation 16 player setup wizard. Click Finish. And if you go to your Start and you type VMware Workstation player, click on it. Now it says VMware Workstation 16 player. Use VMware Workstation 16 player for free for non-commercial use. We are using it for non-commercial, so you could keep that option on and click Continue and Finish. And this is how the VMware Workstation looks like. As you could see right here, it's telling you non-commercial use only. So make sure you're not using it for any other purpose, just for educational purpose. And then you could go ahead and create new virtual machines in this workstation and install any operating system. I'll see you in the next lecture. All right, folks, so we have set up our lab environments. It's already set and go. Now let's take a look at how the RHCSA exam environment is going to look like, where you're actually going to go in and what you should expect. So the very first thing is you will be given a computer. You will have a live system rather than answering those multiple choice questions. So there's no such multiple choice questions. Everything will be the performance based. They will be asking you to perform certain tasks, and this is how they have formatted the entire exam. So the computer that will be given to you, it will be either a Windows machine or Red Hat machine. It doesn't really matter. But when you log into that computer, when you're given access to that physical computer, then you will see two virtual machine inside of the computer where you have a virtualization software installed, and that software will be running two virtual machine, and they are named either node 1 and node 2, or server X or server Y. It doesn't matter. So these are the two servers that you will be using. They will have these Linux operating system running on these two virtual machines. Now, for the very first server, which is node 1, you will have, or you will be given, a username and password for that Linux machine. And for the node 2, you are not given a username and password. Now, a lot of time, students get confused right here. So pay close attention, guys. If you are not given a username and password for Node 2, do not panic. At this time, they are testing whether you know how to recover a root password for Node 2. You will have a console access to these virtual machines. So all you have to do is boot this node 2 into a single user mode and recover the root password. How you could recover the root password, what are the instructions, that I will cover later on in this course. So don't worry. But anyway, as soon as you get into the exam environment, this is how the environment is going to look like. Hello everyone and welcome to the section 3 of this course. This section covers everything that you need to know in Red Hat System Administration class, which is RH124. This is the very first class you have to take, followed by the RH134. Combining these two modules or classes will be able to successfully move you toward achieving your certification. So please focus, stay with me, and we'll go through together and cover everything you need to know in this section. Hello, beautiful people, and welcome to Accessing Linux File Systems. File systems that we already know is a structured way where all the files and directories are stored. And what are the different type of Linux file systems? There are ext2, ext3, ext4, xfs. So there are quite a few file system in Linux or in specifically in Red Hat or CentOS. That's how the files and directories are saved. To access those files, we need some kind of navigation tools. And following are basic tools or commands that are used to access the files that are saved in these file systems. Some of them are ls, which we have already covered, but we'll go through it really quickly. We'll skim through it. So ls, which is list, cd to change directory. PWD is to print a working directory as to exactly where you are right now. DF is to list the file system on a disk, and DU is to disk usage. The file system, if you wanted to know the disk, where is it used, which again we have covered, but we'll go through it really fast. Just as a quick uh, reminder or a quick um, then we have F Then we have DU, which is a disk utilization. Again, we have covered these already, but I'm covering it again, and again, I'm doing it very quick, just as a refresher, since we are on the topic of accessing Linux file systems. Then they will cover a new command, which is the fdisk. That is the command that is used to create file system or create partitions. Then we will cover the absolute and relative path. Absolute path always begins with slash, and what is the difference between both? We'll cover that. We'll also cover how we could use tilde or the symbol that you have right above the tab key, how we could use it to navigate the file system. And the last one we have dot and dot dot. We could use that with our cd command to navigate the file system. All right, so let's get into a Linux machine right here. I have the terminal open. Let me drag this down a little. Okay, now the very first thing we will learn is the ls command, which we have covered before. So ls, if running without any option, will give you the list of all the files and directories. And in this case, it's giving me, because I'm in the GUI based system, console int is giving me blue for directories and the non-color just simply white for files. So if you wanted to see this list in a column, then you do ls minus l. So you will see it'll give you more information. The first column is about the permission, the second column about links it has, who owns it, which group owns it. This is a size, month, date, time, and the name of the file or a directory. There are many different options that you could use with ls, and that can be used to list the files that you have in your directory. You could do ls or lslt for time. If you wanted to see the newest file on the top and the older file at the bottom, then you could do ls minus lt. If you wanted to see in that same thing in reverse order, you would use ls minus ltr. So anyway, this is how you list the files that is inside of your directory. The next command we have cd, which is how you could change directory. So um, if I wanted to go inside of this directory, so this is a directory. How do we know this is a directory? Because it has D right here in front of it. And I could go into this directory by simply typing CD and downloads. I am already in that directory. Now I could do ls to see what's inside of the directory. There's nothing inside of the directory. It says total 0. I could go back. If I wanted to go back, how do I go back? That is something that I was going to cover at the end. But as we are going through, I'm going to probably going to change or go to one or the other. The order doesn't matter. So anyway, um, if I wanted to go back one directory, I could do cd dot dot. It's gonna take me back to that directory. Now the next command that I'm gonna cover is pwd, which we covered earlier again, which is pwd print working directory. This tells you which directory you are in. I am in slash root directory. If I wanted to go to my home directory, which is ifzol directory, I don't see it because I'm not logged in as myself. Who am I logged in? I'm logged in as root. So if I want to go to ifzol directory, then I have to go to cd slash home. Which directory I'm in? I'm in slash home. And what are the files and directories inside of that directory? I could do ls minus l. I'll see the directory inside of home has another directory called ifzol. I want to go into ifzol. I'll do cd ifzol. And now which directory I'm in? I'm in slash home slash ifzol. I'll do ls minus l again to see what are the files and directories I have inside of my ifzol. And these are the directories and files. Okay, this covers ls, cd, pwd. Next one is df, df minus h. This is something that we used earlier. This gives you the file system, the size, the used available, the usage in percentage, and where is it mounted at. The next one is du disk usage by files. You hit enter, you're going to get the list of all the files that you have in your file system, and it will give you the size of each file. Okay, then we have fdisk. This is the new command. Fdisk allows you to actually create disk. In the next section in RH134, we will use this fdisk to create standard partition. We'll create the LVM partition and mount it to standard partition. And there are a few things that we will do in the next section. But for now, to show you what is the functionality of fdisk, we will run fdisk, and this one just you cannot just run it by itself. You have to specify the option, and the best option to specify is fdisk minus l. This is going to list all your file system and where is it mounted. So let's start from the top. Right here I ran this command. Fdisk is telling me I have a disk which is its name is devsda, and it is 20 gig in bytes and sectors, units, and then sector size, IO size, a disk label, disk identifier, and then it's telling me I have two partition on disk SDA. What are those partitions? Those partitions are devsd1 and devsd2. Devsd1 is 2 gig, and the devsd gig is the bigger size, which is almost 19 gig. When you convert that into kilobytes, or sorry, megabytes, it's going to equate to this number. And it's telling you the type, file type right here is SD1 is Linux, SD2 is Linux LVM. Why there's LVM on this one and why not on this one? It's because SD1 has been mounted on slash, let's check fdisk minus h. See right here, dev SD1 has been mounted on slash boot. And for that boot, you don't need LVM, or sometimes the swap space that's carved out, you don't need LVM file system. This one is LVM file system. That's why it has this starting dev mapper. All right, let's clear the screen, go back to fdisk again, and I'm going to just do simply more. Okay, so now coming down right here is telling you after these partitions give you more information. Right here, this is the LVM information that is the name of LVM that is on this device, devsd2. This is the actual name, but when you configure it on the LVM, what is LVM? We'll cover that later. This allows to give you quick information. LVM allows you to create redundancy within your file system. All right. For this dev mapper, his information is telling you, and for the swap space, this is telling you this is 2 gig. If you wanted to create a new disk, let's say if you attach a new disk to your uh, to your Linux operating system, then you would come in here and run fdisk, and then you have to specify the name of the disk, which is would be dev sd slash sdb in this case, b, because SDA is already taken, and then once you run it, then it will give you more option how you could partition that disk. All right, moving on to the next one, which is absolute path and relative path. Let me clear the screen. Absolute path is something that you could CD into it by specifying a complete path. For example, right now I am in slash home and slash ifsol. If I hit CD, hit enter, and right now it's going to take me to the root home directory, which is slash root. Now, what if I wanted to go to slash home slash ifsol and slash um, desktop, for example? One way to do that is you go cd slash home, hit enter, do which directory you are in. You are in home. What's inside? It's ifsol. Then you go again cd ifsol. Then you go again cd desktop. That's how you come and enter or cd into slash home slash ifsol slash desktop. This type of mechanism going from one directory to another directory, that is relative path. Now, if you wanted to go directly to ifsol directory, then let's cd first again. Then you go to cd slash home slash ifsol ifsol slash desktop. Now you're going straight into that directory. It's sorry, I'm missing L. There you go. So now I'm going straight into that directory. Here it is. See, this is the directory. The next one is tilde. So let's say I am in that directory. If I do cd just tilde, then tilde means that go to my or this user that is logged in, go to its home directory. If you do pwd, you see right here, it's giving you slash home. If you do not type tilde, you just type cd, it will still bring you to your home directory. And the last thing that some of the things that I've covered, dot and dot dot. So if you do cd dot, it will keep you in the same directory. But if you do, let's say if you go cd home ifsol slash desktop, then you could do cd dot dot. It'll bring you one step back, cd dot dot one step back, cd dot dot one step back, and there you are. You are in home directory. So that's you. You're like coming back in a relative pathway. So these are the files. These are the commands that you need to access Linux file system. Hey folks, in this video we are going to learn how to access our Linux system. There are mainly two ways to access. One is command line and the other one is through the GUI. And in order to access GUI, you have to get into your Linux machine through the console. Now, for this entire course, I will be using Linux Red Hat 8. I will also be using Red Hat 7, and I will be jumping from console to terminal, terminal to console as well. So the main focus here is that you learn the commands. And if I'm using those commands on Linux version S7 console, then it means those same commands are applicable on version 8 as well. So don't get confused or don't get alarmed if I'm using one terminal or one version to another. The main purpose of this entire course is that you could get your certification in Red Hat version 8. Okay, another thing, for those of you who are already into the Linux system access and you already know how to access it to the command line and GUI, then you could simply go ahead and skip this lecture and go to the next one. For those of you who are learning for the first time accessing the Linux system, then stay tuned. Okay, the first thing is how we access it through the console. You go straight to the in front of the computer, or if it's a physical machine, you connect your monitor and you access the console. Or you could actually access the console through the your hardware console access, which is for Dell, there's iDrag, for HP, there's ILO. For those who are using virtualization software like I'm using, then you could access it through your virtualized software. All right, the next thing that you could access your Linux system is if you're using Windows 10 and you wanted to access your Linux machine remotely, then you will have to use a terminal or a client that is called PuTTY. So PuTTY is a terminal. You could use other terminal as well. There's TerraTerm, Secure CRT, doesn't really matter. Anything that is compatible to run on Windows, then you could use that to connect to the Linux machine. Then another third way of accessing your Linux system is if you are using Linux and you want to access another Linux machine, whether if your source machine is Mac OS or Linux Solaris or Linux CentOS or Red Hat, doesn't really matter as long as it's a Unix-based computer. Then you could simply access your other Linux machine remotely by opening up your terminal or using your SSH command. We'll cover that all one by one. So very first thing is accessing through the console. So again, I'm using my virtualization software, which is Oracle VirtualBox. So I'm going to open up my Oracle VirtualBox. I have these two Linux VMs that are running. One is my first Linux VM, which is running on Red Hat version 8, and the other one is running on CentOS 7. So if I have to access the console, I could just simply click on it and click start. But since it's already running, it's not giving me the option to start. So where is it? Right here. This is my console access. So you could just simply click inside. Your username will already be displayed. Enter your password, and there you have your console. You could open up a terminal in your console so you could run commands. You could click on this little hat, activities, and see right here it says terminal. Click that, and there you have your terminal where you could run commands, which we will cover later on. Okay, so that's about covering from Windows. Sorry, from accessing through the console. Now, next one is if you have Windows and you wanted to connect remotely to a Linux machine, then you need a client called PuTTY. You could go to putty.org and download and install that client. I have already installed it, so what I'll do is I'll simply access it by entering PuTTY into my search. It will open up the program. It will ask which computer IP address of Linux machine you want to connect to. Now that we need to find out. If you are connecting to, let's say, Red Hat 8, so I'll go to my Red Hat 8 console, which is right here, and I'm gonna find out the IP. In order to find out the IP, you need to run a command ifconfig. And since the window is a little smaller, so right here it says this is one adapter, virtual bridge, ignore that, local, ignore that. Scroll up and come to the one where it says ENP0S3. Here, your IP address of your machine is 10.253.1.17. Put that IP address here. Okay, another thing to remember is if you do not have the ifconfig command in your system, when you run it, it probably say, hey, command not found. Then you could use a new command that is available in the newer version of Red Hat 7 and 8, and that is IPADDR. Hit enter and you will see the IP that you're looking for associated with this adapter ENP0S3, and right here it says INET 10.253.1.17. Again, depending on your network, your IP address is most likely different from mine, but the point is you need to pull the IP address so you could input that into the PuTTY and access it. .253.1.17. Hit enter, and there you go. You have a console log, sorry, terminal login. So put in your username and password. Now, this is a terminal SSH access. Here, you do not have a GUI like you have it here. So just keep that in mind. All right, so that's how you access from Windows to your Linux machine. Now, next one is Linux to Linux. So for that purpose, I have my two Linux machines. One is Red Hat 8, which is right here, and the second one is CentOS 7. So let me log into CentOS 7. Okay, so let's say if I wanted to connect from my Red Hat 8 to my CentOS 7. So Again, find out what is the IP address of CentOS 7. For that, right click, open terminal, if config, same command, go up to your adapter where it says ENP0S3, and here you have an IP address of 10.253.1.59. Now you could access that through the terminal and that terminal right here on the GUI, or you could access that on your PuTTY session, which is right here. And all you have to do is type it in the IP address of the machine, of the Linux machine you want to go to, and that is SSH minus L. L is to specify the username, which is ifzol, and the IP address 10.253.1.59. Hit enter. It will ask you to confirm your fingerprints if you're connecting for the first time. Click yes and enter your password. And there you are. Now you are connected from Linux machine to another Linux machine. If you want to get out, simply type exit and you will come back to your original Linux machine. All right, so we covered how to access console directly. We covered Windows access to Linux through PuTTY, a terminal, and we covered from Linux to Linux through the SSH protocol. Again, I will be using one method or the other. I will be using Red Hat 8 version. I will be using CentOS 7 version. But anyway, whatever I'm using, you could try on your Red Hat 8 because it will work on Red Hat 8 as well if I'm trying on 7. Because at the end goal is that you become so familiar with the Red Hat 8 environment that you will be able to pass your RHCSA certification. I'll see you in the next lecture. Hey folks, welcome to Configure and Secure SSH. What exactly is SSH? SSH stands for Secure Shell. All right, now what is a shell? Well, shell provides you with an interface to the Linux system. It takes in your commands and translate them to kernel to manage the hardware. So let's visualize it. So we have our hardware. So whatever the hardware that you have, Dell, HP, doesn't really matter. So on top of that hardware, the layer that controls that hardware is the kernel layer. And who actually controls that kernel layer? The shell. So there are different type of shell. There's corn shell, C shell, bash shell. The shell, when you actually log into your Linux machine and you get a prompt and you type in the commands for those prompts, that environment is a shell. It's actually a platform that's given to you to control or give commands to your kernel, and then you run utilities on top of that shell. So when you are given the shell prompt, you run commands like ls, pwd, copy, or whatever the commands, the Linux standard commands or other commands that you could run. All right. So if you notice, you're probably familiar. You look at that shell. It's most likely, if you're not going to the console, if you're putting into it or terminal into it, the shell looks like that. In most cases, the regular user, when a user logs in, they get a dollar sign. When a root logs in, they get a hash sign or pound sign. All right, OpenSSH is a package, or it's a software like any other package. So let's say if you're installing a cronid package or NTP package, HTTP package, so that package SSH is also a package, and that package name is OpenSSH. By default, when you install Linux or Red Hat on your computer, that OpenSSH package comes installed on your system. Its service daemon is SSHD. A daemon is something that runs in the background all the times and listens for commands or executions. So when we run OpenSSH, it starts as daemon and that daemon name is SSHD. You could stop and restart its daemon if you know the name of the daemon. So now which port that SSH service runs on? By default, the SSH port runs on port number 22. Many programs in Linux have a dedicated port numbers that by default they run on. All right. SSH itself is very secure, meaning communication through SSH is always encrypted. But there should be some additional configuration can be done to make it more secure. All right. Following are the most common configuration an administrator should take to secure SSH. Now, I'm going to go through some of these configuration. And by the way, those configuration are not just the only ones. There could be a lot more, but the very most common ones are as follow. The very first one is configuring idle timeout interval. It means avoid having an unattended SSH session. You could set an idle timeout interval by following this direction. So, idle timeout meaning when you log into the system or when you put it into the system, and let's say you are being pulled into a meeting, but your computer or your login session is still there. So, if you leave it open, maybe it's vulnerable and someone could get access to it. So, it's better that you set the timeout interval. To set the timeout interval, you have to become root, edit the etc ssh underscore config file, and add the following lines, which is client alive intervals 600, client alive count max 0, and then you have to restart the daemon, and the daemon is sshd. The command is systemctl restart sshd. The idle time interval you are setting is in seconds, so we set 600, which means it's equal to 10 minutes. You could change it according to your policy, your desire, your standards. Once the interval has passed, the idle user will be automatically logged out. All right, so if I go into my Linux machine, I have it open right here. Let me log in. I will log in as myself, and let me open up the terminal by going to Activities, Terminal. Okay, here I am logged in as myself. I have to become root, su-root. Now, before you modify the sshd underscore config file, it is always recommended, that's my recommendation too, a system administrator should always make a backup copy of that sshd underscore config file, or any file in etc for that matter. In case you make a mistake, you can always revert back. So what I'll do is I'll do copy etc sshd underscore config, and what's the location? I'll put it in the same location, sshd underscore config, and I will do dash orig, meaning that's the original file. Okay, so copy is done. Now, if you have to set that um, interval timeouts, then you have to edit the file by viing the file etc sshd underscore config, and then you have to add these lines. These lines don't already exist, so it's best that you add these lines toward the end of the file. So in order to go to the end of the file, type shift G, and it will bring you to the end of the file. Now hit O to start a new line. You could put a comment here, setting interval, setting timeout interval. And now you could type it in client alive interval space 600. Same thing, client alive count max 0. So now when you escape and save the file, and now it's time to restart your systemctl. Systemctl restart sshd. When you get your prompt back, it means the system took the setting and it was not any wrong setting. By the way, if it is just for you to show you, if you do not have to set these settings in your environment, it's not a requirement, then talk to your security guy and ask if you should make that changes before getting any approval. All right, so what I will do just to make sure we have consistent setting in our file, what I'll do is I will copy etc ssh sshd underscore config, under dash orig file to its original configuration. It will ask overwrite. Yes, overwrite. So now if I go vi the etc ssh under sshd underscore config file and go to the end, you will see that setting no longer there because I override it. All right. So if you need to keep that, it's really up to you. All right. Then coming back, the next setting that we should do is disable root login. Disabling root login should be one of the measures that you should take when setting up the system for the very first time. It disables any user to log into the system with a root account. So you should definitely do that so no user can log in directly with user root and the root password. All right, in order for that, you could go back to your system, and right here is telling you that you have to edit the file and replace permit root login to yes and replace it to no. Okay, so let's do VI again and let's find out where that configuration is or where that parameter is. In order to find that parameter, you type in slash and then permit root login. Hit enter and you will see right here it says permit root login. Replace yes to no, save the file and restart SSHD. All right, moving on to the next one. The next one is disable empty passwords. So you need to prevent remote logins from accounts with empty password for added security. So any user that does not have a password, they should be limited. They should be forced to not log in unless they create a password. And for that, you have to edit the file and remove hash sign from the following line. So let's go to our Linux machine, VI the Linux machine again, sorry, VI the configuration file again, and look for permit empty passwords. Right here, that's a parameter. So if you remove this hash pound sign and save the file and restart the daemon, then it will take those configuration. All right, moving on to the next one. Limit a user's SSH access. To provide another layer of security, you should limit your SSH logins to only certain users who need remote access. So if you know that John and Jason and Peter, those are the three users that only need access to your system, then why keep it open to everyone? Just give them the access, and then by default, automatically everyone else will be denied. For that, you have to edit this file and add these lines. So allow users, user one, user two, whichever the username that you have created in your system. I would say, since we are adding this line, I would say you have to go back to your Linux machine and go all the way to the end by entering Shift G. And here, always, anytime you add any new parameters, always put in the comment that allow the following uses only. And then you would do allow uses, for example, IFZEL or J Smith or whatever that you have. Then save the file, restart the daemon. So I'm not saving it since we are doing only for lab purposes. I'm just going to quit. If you saved it, then you will have to restart this SSHD. All right, moving on to the next configuration. Use a different port. Now, we do know that SSH runs on which port? Yes, it runs on, by default, it runs on 22. So, most rackers looking for any open SSH servers will look for port 22. So, changing that can make the system much more secure. In order to change that, you have to become root, edit your sshd underscore config file, and remove that hash sign from the following line and change the port number. So you already have a port number there. By default is 22. So let's go into our Linux machine. VI our sshd underscore config file. By the way, as you're going into VIing the file, please continue to make copies. Now look for port 22. So simply type slash and type it in uppercase P-O-R-T, hit enter. It will bring you down to the line which has that key, that matching word. Right here it says port 22. Now, if you wanted to change to a different port, you have to get rid of this hash sign and put in the port number 22224, for example. Now, how I'm coming up this with on this port. First of all, this is a very huge, big port number. None of the programs that comes in the Linux system have any of these ports assigned. Still, I want you to make sure whatever the port that you're assigning to this SSH is not being used by any other programs. You could search online to see which ports are available that can be used for SSH, and you will find a lot of them. All right, so anyway, I'm not changing the port. I'm just gonna discard any changes by quitting the file and getting out of it. So if you have make changes, you have to do systemctl restart SSH, and that will set your port. So next time when you are trying to log into the system through SSH or PuTTY, then you have to change that port. For example, if I open up my PuTTY session, right here, I will put in the IP address of my Linux machine, but you see right here that by default is giving me port 22. So if I try that with port 22 and click open, it would not let me get in because I have changed the port. So I have to put in that port that I picked, which was 22224, for example. Then put in the host name or IP address and then click open, and then it will allow me to connect. All right, moving on to the next one, which is SSH keys. Access remote server without a password. Okay, so remote server, you have a Linux machine, and if you are trying to access that from a Windows or from another Linux machine, for example, then you could actually skip entering the password because you would have the keys. By the way, that lecture I have done in the next one. So stay tuned, go to the next video to understand and configure your SSH keys. Hey everyone, and welcome back. In this video, we are going to talk about controlling our services or the applications and the daemons. All right, so service or applications, when they are started, they create processes. And when those processes run continuously in the background, they become daemons. And I have explained that previously what a daemon is in detail and every aspect of a service, a process, or a script. So, most services that we run in our system or in a Linux environment and they run continuously, they are daemons. Services are controlled by systemctl. Systemctl is a systemd utility that is responsible for controlling the systemd system and service manager. Systemd is a collection of system management daemons, utilities, and libraries, which serves a replacement of System 5 init de or init daemon. So that was um, previously that was initd, which was also a command that we used to run in an older version of Linux, which was a service. But now that command service has been replaced with systemctl or system control. All right, systemd is the parent process of most of the daemons that we have in our Linux environment. And the command to control all these services is a simple systemctl. So every time you install an application or a package or a service in your Linux environment, then you could control that program by running the command systemctl. In this slide, I'm going to list some of the basic commands a system administrator should know to manage or control the services. First one is to check if systemd is installed on your system. Then check if the systemd is running. Check all running services to check the status, start, stop, and restart of a service. to reload the configuration file of a service to enable or disable service at boot time when your system shuts down and starts back on. This will allow the system to find out which service to start at that time along the operating system. Then to enable and disable a service completely, regardless of boot or manually, this is the command. So these are all the list of commands that we have and that you should know and remember as well in order to control the services. So I'm going to go over all of these commands one by one in our Linux system with you. All right, so I have my Linux machine open right here. Okay, the very first thing is we need to know if we have the systemd installed in our system. Now, systemd comes by default installed on a Linux operating system version 7 and 8. And by the way, I'm referring to Red Hat and CentOS operating systems. So the earlier versions of the operating system might not have a systemd. It will have a systemv, which had the init d mechanism. So let's find out by running the command systemctl dash dash or hyphen hyphen version. Right away, it tells you this has a systemd installed with version 239, and it is 239-45 and EL Red Hat, Enterprise Linux 8. That's what we are running. Now, depending on when you are watching this video and depending when you have installed the Red Hat operating system on your virtual machine, the version could be higher, or maybe you had it installed and you're watching this video later, then you might have an older version. It doesn't matter what you have, what version you have. What matters is that you have systemd package or applications that controls all your services have installed. All right, the next one is check if the systemd is running. If you have a systemd running, then only then you could actually execute the systemctl commands, which controls the units, or I would say the main is the services, and it has the units. So let's check ps minus ef and grep for system, or more specifically systemd. Right here, you will see the very first service or the process that gets started when your computer starts or when your operating system starts, and this is the systemd process. And if you notice, and to confirm that this is the first process that starts, you'll notice it has a process ID of 1. This process actually initiates all the other major or minor processes of your system. If you want certain processes, for example, cronid, which is a time application, to start at boot time, the systemd is the one that you're going to tell, hey, this is a service called cronid. I want it to start when the system starts. So it has all the other information as well. It has its login D association. It has its journal, its session, and all the other process. Now, if you stop this process, kill it, then it will kill pretty much your entire operating system, because all the other services that are running in your system depends are controlled by system D. Okay, now moving on, then the next thing we have is check all the running services in your system. So we have a lot of packages installed in our system. What are those packages? The command to find out those packages is rpm-qa, and it will list all the packages or applications that I have installed on my Linux machine. What are the total number? I could do pipe and wc minus l. I have a total of 1377 packages installed. Now, does it mean that every package that I have installed has its service loaded and started and running? No, there are only few services that are running. The other packages are just there in case it is needed or you need to start it as an ad hoc or by request. So, what are the list of services do we have running, or do we have enabled or not even started? So for that, you will run the command system ctl dash dash all, and automatically by default it will give you one page at a time. So here you have from line 1 to 25, and as you hit the space bar you will see all these services on the left hand side, is status, whether its configuration file is loaded or not, and what's its current status at this time. It's active and loaded, and it has a sub status, which is plugged in, if it's a plugged in or not, or if it has another dependency on another system, if this requires mounted, like this boot.mount. This is actually a service. Remember we talked about the file system mounting. It is mounted on slash boot. But to manage that process, or to manage that mounting of that slash boot, that is managed by your system CTL. All right, moving on. For example, sysroot.mount, that is inactive, not found, dead. It would try to install it. This sysroot is probably an older service. It does not have a package, but it has a service, but it couldn't find it. Then you have other services as you go down. Right here it says firewall D, for example. This is a firewall that allows you to protect your system from incoming or outgoing traffic. So it says its configuration file is loaded. Beautiful. The service is active and it is running. So there, it could be the service is up, and service could be active, but it's not running. So the third column is pretty much all the threads, all the sub processes that are needed to run with that service. Okay, if you go down, hit space bar, and you will see all the inactive loaded, all the services that are actually available to us to manage by the system CTL. Okay, now the next one is to check the status of a service. You could run the command systemctl status, and let's move it to the right, application dot service, which the application itself right here will be replaced by with the name of that service. So in this example, what I'm going to do is I'm going to take the service of firewall D. So let's check the status of firewall D service. System CTL status firewall D. This is the application name, and we wanted to check its service, so I'll put it dot service. Okay, right away, it will give you all the information that you need. The service, the configuration file right here is telling you right here is a user lib system D system firewall dot. These is the service, is a library. It's loaded already. It's getting all its instructions. Now, the actual status of the service, has it been started? Yes, it is started, it's active. And all the required processes that are needed for this service to be active, are those processes running? Yes, they are running. When was the last time they ran? This is the date, time, and 4 hours 47 minutes ago. The documentation for this is right here. If you click it, it will open up a page that will show you the documentation of this firewall D. The main process ID for firewall D is 890. Now, if you use the command right now, kill 890, it will kill this service, but that's not the right way to stop the service. To stop the service, what you have to do is system CTL stop firewall D dot service. Okay, it gave us our prompt map back without any error message. It means it worked. Now let's check the status back again. And now you will see the service, the configuration file is loaded. However, the active or the status is inactive or dead. It's not up and running. You could also check the status of a service by running ps-ef grep firewall D, and you will see there is nothing that came up. Only came up right here. Please don't confuse this with actual service, because this is basically telling you the command that I ran. I ran a command grep, and I wanted to grep for firewall D, and it's basically bringing it back, that command back to me, that hey, here's this process, because that command when I execute is a process of itself. Okay, now if I wanted to start that service back again, hit up a arrow key and just simply replace stop with the start. All right, it started. Let's check the status again. Okay, there you go. Status is loaded and it is up and running. Now here's another one that you should know, which is restart right here. Now restart, you need restart is when you make changes to its configuration file. Let's say you wanted to change the behavior of a firewall D, how it functions, or you making firewall D allowing a port enabling or disabling or anything that you have made changes to the configuration file. Then instead of you to stop and start, you could just use one command, that is simply restart. It will stop for you, it will start for you. All right, stopped and started. How do you know it has came back online? Again, status, and status will give you that information. The right here, this is pretty much a quick log which tells you when you executed the command what happened. Firewall D succeeded, firewall D stopped, firewall D started, and all the information that it pertains to the firewall D service. Okay, now what if you are trying to stop the service from here and you cannot stop? Something is wrong. That's when you have to actually come and kill that service. So you could do kill the main process ID, which is 37427, hit enter, and it is killed. Now, if you wanted to check the status, you see right here it says loaded, but the service is inactive. Okay, so as I said, killing or using a command kill is not an efficient way or a graceful way to stop a service. The best way to stop a service is by doing systemctl stop. Anyway, to start it back again, we could use start and it should start back again. Let's check the status and it has been started. Next one is we will talk about to reload the configuration of a service. What is a reload, or what is the difference between stop, start, or restart and reload? Okay, so reload is not going to impact your service whereas stop and start will impact your service. If you are running a service, for example, Apache service name is HTTPD. So as soon as you make a configuration changes on Apache and you stop it, then you're gonna lose the page. Anybody who's on your website, you will lose it, and until you restart it. But if you're making changes to your configuration file and you use the command reload, then it will reload the configuration file back again to systemctl without stopping and starting the application. That's the beauty of reload. We could run it just to for the demo purposes. Reload, and it is reloaded. Okay, now moving on is to enable or disable a service at boot time. So if you want this service to boot while your operating system boot, or in other words, if you want firewall D to start when your operating system starts with that, then you have to enable that service. To enable it, you could just simply type systemctl enable and it will be enabled at boot time. Now, if you wanted to have, by the way, how do you check if it's enabled or not? You could do the systemctl and right here on the loaded, right here where it says enabled, that's when it's gonna tell you the status. See right here, it is enabled. Okay, now if you wanted to disable it, which means that you don't want it to start when the operating system start. So simply there are a couple of links that it has to remove, but anyway, let's check the status and you will see it is disabled. Now if you reboot your entire operating system, it will not start your firewall D service, but it doesn't impact the existing state. Okay, so let's clear the screen. The next one we have is to enable or disable a service completely. And you're probably thinking, hey, isn't it the same one we just covered to enable or disable at boot time? Well, yes and no. Yes, it will disable if you choose to disable at boot time during the operating system. It will not boot the service. However, it is possible if a service, for example, A has to start and it requires another service, for example, service C, to start with it. Then, regardless if that is enabled or disabled, it will start that service. So, for example, let's talk about in a real life situation. For example, if you have a cronny D or even HTTP service that it starts. Now that service requires to start another service that, let's say in our example, firewall D. Then regardless if the firewall D is enabled or disabled, it will start. Now if we have that service masked or unmasked, then doesn't matter which service try to request for that service to start, it will not start. That's pretty much a simple and straightforward differences. So if you do system CTL and we do, for example, start again, oh no, status to check firewall D service, you see it's up and running. Now to unmask, first let's see if it has mask. Let's create a symbolic link. Now to unmask, you could just simply type unmask and remove the symbolic link. Now, if a service A comes in and it wants service B to start, and that service B has been unmasked, then it will not start, regardless what that service instruction comes in with. Anyway, these are the few commands that you should remember. Especially the systemctl is the main command. You could always find the different options of that and which service to stop and start by systemctl dash dash all. Every service that you have to start and stop is managed by systemctl, or many times nowadays, the third party applications can be managed through systemctl command or service as well. I'll see you in the next lecture.
Creating files and directories. In this lesson, we will cover how we can create files and directories. Different ways to create files. The first one is the touch. The touch command creates a file that is, of course, an empty file. The second way to create a file is if you are copying an existing file and creating a new file at the destination location. And the third way to create a file is through vi command. Now vi is our editor, which we will cover in detail later in the lessons, but I will cover quickly how we could create a file using vi. Creating directories, the easiest way to create directory in the command is mkdir, which is make directory. So now let's get into our Linux machine, and we will use every command listed here as a practice to create our files. Okay, the first thing we have to do is to find out what user ID we are logged in as. So you do who am I, and we'll tell you you are logged in as yourself. And then the second thing, you have to know which directory you are in, and I am in my home directory. Now I will be creating a few files, and as your homework I want you to create those files and directories as well. The first way to create a file, here I have a list of files that I will be creating. We will use the first command to create a file will be touch. We'll create touch space, I have here Jerry. Hit enter. When you hit enter and you get the prompt back, that means your command worked. Now how do we know where is that file? You do ls -l, and you'll see here the directory you have is right here. Jerry. Sorry, not the directory, the file. Now I want you to create another file. Touch Kramer. Again, check if it's created. Yes, it is created, Jerry and Kramer. Now I use the option ls-l, which will list all the files and the directories in an alphabetical order. Now if you wanted to list all the files or directories that are created at when it was last modified, you will use ls -ltr, which means give you everything by the timely order and in reverse, meaning the oldest one at the top and the newest one at the bottom. When you hit enter, you will see Jerry was the first one that was created, followed by the Kramer. Next one we are creating is George. How do you verify that file was created? You do ls-l. Now these files can be changed or renamed or moved, but we'll go to the next set of files to create. I want you to use this time the copy command. So I want you to use copy Jerry, and then the destination file I want you to be Lex. So do ls-ltr. So what exactly it did, it copied this Jerry file and named it Lex. I want you to do the same thing for Clark. So copy Jerry or Kramer or whichever file and do Clark. Same thing, copy Jerry and Lois. Now let's verify we have all those files. There you go, we got all 6 files. So now 3 files we created with touch command, 3 files we created with the copy command, and the rest of the files we'll create using VI. Now remember, VI is a very tricky, so I will only create 1 file and we will cover the VI later. So VI space Homer. So hit enter. Once you hit enter, it will bring you to file editor. Now be very careful what you type in here, because you will not be able to get out if you really don't know what you are doing. So at this point I just want you to do shift : W as in write, Q as in quit, and exclamation point, which is also referred as bang. Hit enter. The file Homer is created. How do we verify it? Let's do ls-ltr, and there you go, the Homer file is created. Now the other 3 files I will create by the touch command. Now you will notice you don't have to run touch command over and over again. You could run the touch command just once and do Bart space Lisa space marg, March. So now with this just one command, it will create 3 files. So hit enter. Verified. All 3 files, Bart, March, Lisa, all of them are in this directory. Now the next step I want you to do is create directories within your home directory. So just do pwd just to make sure you are in home directory. Then from here you do mkdir space Seinfeld. Now the directory is created because you got your prompt back. How do you verify it? ls-ltr, and you see at the bottom that's where the directory is created. And if you notice, some of the Linux distributions also change the color for you, so this way it will be easier for you to identify which one is the file or which one is a directory. Same way I want to create another directory, mkdir Superman, and again you could also do the same way. Instead of running one command after the other, you could just run one command and followed by 2 different directories. So the second directory we have is Simpson. and hit enter. Once you hit enter, again do ls minus ltr. See all three directories at the bottom, and you have all your files right here listed here. So this is the way you create files and directories in your home directory. If you try to create a directory in, let's say, slash or somewhere else where you do not have permission, it would tell you that this directory, you do not have sufficient rights to create that directory. So let's take an example. If you go to cd/etc and I want to create a file here, let's call it test123 and hit enter. It's going to tell you you do not have permission to create that file in there because we don't own slash. Who owns the slash? Root owns it, and you are not root. Who are you? You are yourself. In this case, I have Sol. Again, we learned 4 commands: touch, copy, vi to create files, and the last command we learned to create directories is mkdir.
Hey folks, let's get started with Red Hat Enterprise Linux. Linux, as we know, it's everywhere. It's in cloud, in smartphones, airplanes, smart TVs, gadgets, and many, many other devices that run Linux. So what we will learn in this video is what is open source. What are the Linux distributions and itself, the Red Hat Enterprise Linux, and what are its advantages. So let's dive right in. So let's get started with open source. Open source software is computer software that is released under a license in which the copyright holder grants user the right to use, study, change, and distribute the software and its source code to anyone and for any purpose. Open source software is developed in a decentralized and collaborative way, relying on peer review and community production. Open source software is often cheaper, more flexible, and has more longevity than its proprietary peers because it is developed by communities rather than a single author or company. Linux is a free open source operating system released under GNU General Public License. It's also become the largest open source software project in the world. Red Hat, which we our point, our focus, Red Hat Enterprise Linux is built from open source components. The kernel itself and the supporting software are all open source. However, Red Hat has built infrastructure support and a suite of services that will let you license their branded version of Enterprise Linux and use it in the production. So everything that we have used in Linux is pretty much coming from an open source. And open source is not just those volunteers, guys that are everywhere in the world. They are actually contributing toward the code. Basically, there are companies like Red Hat who actually hire developers to contribute toward the development of open source Linux. All right, moving on to Linux distribution. Let's take a look what are the distribution of Linux. A Linux distribution is an operating system composed of Linux kernel, GNU tools, additional software, and a package manager. So basically, any Linux or any operating system that is built on a Linux kernel is part of Linux or it's a Linux operating system. So let's look at an example of some of the Linux distribution that we have. Well, number one is Red Hat, and we know Red Hat has its own subscription and it has one of the biggest market share in the Linux industry. As overall, the operating system market share right now it is 32.7%. Moving on to CentOS, or CentOS is just like a Red Hat. It's an identical copy. It's the only difference between Red Hat and CentOS is available to you. There is no support given to you. You could use it just like Red Hat, but in Red Hat you could get production or support from Red Hat customer service, so they could provide you technical support. and packages and updates. Moving on to Ubuntu. Ubuntu is based on Debian and it is released in three different editions. One is desktop, second is server, and third one is core of Internet of Things, devices, and robotics. It's very familiar, very famous around robotics. Then moving on to SUSE. SUSE is an operating system, again, an open source operating system developed in Germany. And nowadays, most of the time, SUSE is used for SAP applications. Then moving on to Fedora. Fedora is also an open source version of Red Hat. A lot of times the developers contributed to Fedora um, code, and once that is built, they convert that into the Red Hat. Then moving on to the last one is Kali Linux. Now, Kali Linux is derived from Ubuntu and it is used and famous for digital forensics and penetration testing. So there are, by the way, there are many other Linux distributions as well. I covered the most basic ones that mostly you're familiar with. All right, moving on to Red Hat Linux. Red Hat is one of the leading contributors to Linux kernel and associated technology in the greater open source community. IBM acquired Red Hat in 2018 for $34 billion. Red Hat Linux current version is right now 8. Product lifecycle of Red Hat Linux operating system is 10 years. You could download and use any supported version of Red Hat Enterprise Linux software, meaning that you may upgrade to the latest version for no additional cost. It allows you to have live kernel patching, so avoiding the need for a system reboot if you're running production application. It allows you to access the Red Hat Enterprise Linux documentation and as well as customer portal labs.
Help commands. Now, what are the help commands um, that are used in a Linux environment that will give you some of the information or some help about other commands? There are three types of help command that are used in most of the Linux distributions. The first one is what is. So whenever you run a command what is followed by the command that you want to inquire about, you will run what is and space then command. This will give you a quicker, a shorter version of the information about the command that you're looking for. The next one we have is the command, whichever command you want to run, let's say ls space and then dash dash help. This will give you a little, a bigger, a longer version of the help with more details about that, the options about that command. And the last one is man, which stands for manual. Man space followed by the command name itself. When you run that, you will get a complete full listing of the command descriptions to help about it. So now let's look at our Linux machine and we'll see how these commands work. So we are here in our Linux machine. Let's do the clear and we will find out who we are. Again, who am I? We are ourselves. You type clear. The first command that we learned we're going to run is what is. It's all one word, space, let's say ls. This will tell you the ls is list the directory contents. The next one we'll run is what is cd. That's what tells you the bash built-in command. The cd is a bash built-in command, meaning when you have your Linux system installed, it comes in as pre-built command. And what it does, it changes the working directory from one directory, of course, to another. Well, let's try the same command to what is pwd. Tells you print name of current working directory, return working directory name. So why do we have two different answers for one command? Is because we have two different sources or two different dictionary already installed, or you could say two different manual pages installed on our Linux distribution. There could be more, there could be 2, 3, 4, or 5, depending on what type of command it is and what kind of description it has. Let's look at the next command. Let's say ls dash dash help.
See, there you go. It gives you a little longer description of your ls command, and it tells you all the different options that are associated with ls command. So of course, right here, that's where it starts, and it goes all the way down. It tells you minus a option, minus uppercase option, and so on. We could also run chmod dash dash help. Now remember, chmod command is the change mod command which change the permission of a file. So when we do help, we're gonna say, it tells you, gives you quick description starting from here. It tells you that change the mod of each file to that RF file, change the mod of each file to mode, and a few different options. Same thing, you run this command with other different commands, space dot help. It will give you the information about that command. Now, the last one we're going to look at is the man command. Man stands for manual, and then space, let's say ls. When you run this command, there you go. It will give you a very nice descriptive way, a nice formatted way of the user command information. It tells you the name, the synopsis, the description, and each option of the command. You could do space to go on each page. Hit spacebar every time you want to quit out. Just hit Q and you're going to be out of it. Same thing when you do a man command and then pwd, you do enter, and you're going to see the exact same thing. Pwd, print name of the current working directory and what other options it has. My favorite command in all those help commands is this man command, because it has exactly the information, the detailed information of each command. Hello everyone. In this video, we are going to learn how we could install and update our software packages on a Linux system. A software is an application that you could run on your computer. Just like in a Windows environment, you have a Microsoft Office, Microsoft PowerPoint, Firefox browser, or Internet Explorer browser, calculator. All of those are an example of an application then run on your computer operating system. A package, when you download, it is like a container that contains the software related programs, files, and executable. The operating system is the one that actually unpackages it and then go through the installation of those executables. So what we will learn in this video is the Linux package management using yum and dnf command and rpm command. By the way, yum command is the older command that has been deprecated, not fully deprecated in the newer version of RHEL. Now you could use either yum or dnf. In my lectures, I will be using yum, but you could replace that yum command with dns if you like. Uh, but eventually, the dnf command will be the primary command that will be used for package management. Then we have system update and patch management, where we will learn about the minor or major upgrades, and what is the difference between updating a package or updating your complete system versus upgrading it. And the last thing that we will learn is about the advanced package management. So let's go ahead and jump right away.
System updates and repos. Repo stands for repositories. This is a very important lesson for installing new packages to your systems. So there are two major commands that are used in system updates and repos installation. Is the first one is yum. Yum command is mostly used in CentOS or in Red Hat environment, whereas apt-get is another similar command that is used in other Linux distribution servers. Yum command installs a package from the repositories that are defined in your Linux system. Those repositories, those configuration files, has the URL link for repositories. So when you run yum, it's telling the system go online with this URL and get the package that I'm asking you to install. So in other words, yum does need an internet access to go online and install a package to your system. Then the next command we have is RPM. RPM stands for Red Hat Package Manager. Now, RPM, of course, was first developed by Red Hat and is still in use by Red Hat. But nowadays, many other Linux distributions have carried over the same command, RPM. They never changed it. Now, what's the purpose of RPM? Before I tell you about RPM, let me tell you a difference between RPM and YUM. This way, it will be much easier for you to understand what RPM is. RPM is used when you already have a package downloaded in your system, and then you could install it locally by running the command RPM. Now, whereas YUM does all the things for you. It downloads the package, it installs the package as well. So RPM is mostly used in an environment where they don't have internet access. So let's get into our Linux machine. I will try out both of these commands. Okay, I am logged into my Linux machine as root. Which directory I'm in root directory, and there are different commands, and of course, what is my host name? My host name is my first Linux machine, a Linux OS. Of course, now we know we are not in the wrong system. When you are installing packages, please also make sure run a host name so you don't install packages to a wrong system. Okay, so now the first command that we will learn is yum. If I wanted to install a package, let's say NTP, all I have to do is type yum install NTP. It will go outside to the mirrors or wherever the URL has been specified, and it will look for our NTP package. Now, before it goes outside, it looks for within itself, within its own system, and see whether the NTP package has been installed already or not. In this case, I try to install NTP package, and what happened? It says NTP package has already been installed with the latest version, so nothing to do. Okay, perfect. So I don't have to install it. I don't have to update it. Now, what about if I wanted to install Apache, and Apache package name is HTTP? It will do again the same thing, and if I have the package installed, it will give me the same message that it gave me before. It says no package HTTP available. I believe it's HTTPD. Okay, yes, same message, HTTPD, CentOS already installed and with the latest version. Okay, so now before we go ahead and try a third package to install, I wanted to check if that package has already been installed in my system or not. And to check that, I have to run the command rpm minus, which is the option, Q for query all the package that I have installed in my system with A option. When you hit enter, it went into my list of packages that are installed. It is giving me every single packages. Of course, there's so many of them. What if I wanted to know how many packages I have installed? I will do simply wc minus L. This will give me the total number of packages that are installed. Of course, WC minus L in this case is not actually counting the packages. It's actually counting the lines, the output of RPM minus QA. This is telling me there are 1,350 packages installed. Now, I wanted to install a package for DNS. Now, before I install a package for DNS, I wanted to check if that package is installed. So I'll do RPM minus QA grep, and the package that needs to install associated with the DNS, it's called bind. I'll do RPM minus QA and grep for bind only. And you will see here it has the bind libraries, key binds, bind libraries, bind license, RPC bind, and bind utilities. So there is no package with just bind. So it means I don't have DNS installed. So what I will do is I will install by running the command yum install bind. When I hit enter, Now it's doing the same thing. It's going outside on the internet to all the repositories that are defined in my configuration files. And it's coming back with the package saying, hey, I found this package called bind, and its architecture version that I find, which matches to your system, is 64-bit. The version that you will be installing of bind is this. Repositories is the updates repository, and the size is 1.8 megabyte. The transaction summary is right here. Install one package. Total download size is going to be 1.8 meg. So I'll go ahead and it will say, is it okay? I'll say yes. Go ahead and install that package. And if you see the progress, depending on the speed of your computer, how fast it is connected to the internet, that's what matters in doing the download and install. So right now, if you see, the yum is doing two things for us. One, it's downloading the package. Once it's completed downloading, then right here, it's installing the package. It's installed. Once it's installed, it verified it, and it has confirmed that it has installed the package. Now, how do I verify again manually? By running the command rpm -qa grep for bind. Okay, and now this time you will see right here, yes, the fourth line. This one is just simply bind without any libs, license, or any other extra packages that needed for bind. So yum also installs any dependencies, meaning if there is any other packages that is required with this package, it does it for itself. Whereas RPM, if you have one RPM package, when you run the command, it will tell you, hey, I don't have that dependency, so you have to install that package as well. So to go back to our RPM command, to install a package, you have to use the command rpm -ihv, or you could change that to hiv, whichever the way you want, space the location of your RPM. So if you have downloaded your RPM in, let's say, temp, then you will specify /temp/ package, whatever the name of the package is, and usually the package ends with .rpm. Then when you run this command, it will install that package for you. Now you could also do rpm -e to remove a package. So let's say if I wanted to remove this package, bind, the one we just installed. So I will have to type here now bind error package is not, sorry, I did some kind of mistake. So rpm -e, let me see if I could copy and paste. Should be able to do that. Yes, copy and paste. It's gone. Now can I verify it? rpm -qa grep for bind. Okay, you see it's not there. So what do we do now? If I wanted to install it back, I will do yum install bind. Click yes to install it. Yes, it is downloading again, same process, and it's downloading. Now you probably be thinking, hey, didn't it download when we did the same command before? Yes, it did download, but yum is very smart tool. What it does, it downloads, it installs, it verifies, and it also cleans up your download. So your space, this space is used more efficiently. So it doesn't keep the old downloads on your system. Okay, so now the download is completed. Let's check again if we have the package. Yes, we do have the package, and package is right here, the first one. Now we use the rpm -e command to remove that package. Now we could also do yum remove bind. and it will do the same thing as if I would do RPM minus E. So it says remove one package. Yes, go ahead and remove it. System upgrade or patch management. This is a very important topic, very important lesson for this training. You will be upgrading your system from time to time or applying patches to your system on a quarterly basis depending on your company's policies. There are two types of upgrades that happen in Linux operating system. One is the major version upgrade, which is from 5 to 6, 6 to 7. And if you don't know what version of Linux we are running right now, then I would tell you right now, stop everything. Again, stop everything and go back to your Linux VM and find out what version you are running. And you will find that out how you could do cat at c redhat -release or uname-a, or there are different ways that we have talked about previously. So anyway, just to let you know, if you don't know, if you forgot, that is fine. The version that we are running in our Linux machine is 7, and the minor of that version is 7.4. So there are two types of upgrades. Major versions 5, 6, or 7, and minor version from 7.3 to 7.4 or 7.1 to 7.2, or that stays within the same channel, which is like 7 all the way from 1 to 5, 6, 7, wherever it ends. The major version you cannot get upgraded through the yum command. Minor version can be done through yum update command. Major version you cannot do. How you could do the major version upgrade? Well, you have to back up the entire server, build a new server from scratch, and transfer files. There are a few other ways that you could do it, but trust me, it's very cumbersome. Example to do your update is simply running a command yum space update and option -y. And the reason we have -y is because this is telling the operating system every time you're going to prompt me to install a certain package, don't ask me, just install it. So for every question, my answer is yes. There is another way to do the update, is update and upgrade. Now, what's the difference between update and upgrade? Upgrade deletes packages. When you have a package, let's say you have an NTP package or HTTP package, and you did yum upgrade, it will delete the old package, which is, let's say, HTTP.5, and it has a new version, HTTP.6. So it will delete that old package and it will update it with the newer package. So that's the difference. Whereas upgrade preserves. It preserves the older packages as well. Why? Because it is a good practice for some system administrators to keep old packages in case they have certain of their applications don't comply or don't run with the newer version of the packages. So that's why sometimes people have to roll back to its original patch updates. So system upgrades and patch management, this is just a quick lesson for it. I will go into my Linux machine again to try out a few of these commands. I want to go in as putty. So in order to go in as putty, what do you need? I am keep typing this, so this way you guys would know this command or networking of a Linux machine. So this is the IP. You put in the IP address in the Linux machine. I already have the putty open. Who am I? I'm root. So just minimize the console, and now I have open putty. So the first thing is right here, yum update. Again, when you do the yum update, it will preserve old packages, whereas upgrade will delete old packages. But before we go any further, what version do we have? Have you checked that out? So you do etc Red Hat release. We have major version 7 and minor version .4. So we will do yum update. We will not put -y because I will show you when it will ask you if I wanted to proceed. So just do yum update. It is actually going through all the packages that require an update, and it is telling you right here at this summary, let's scroll up, that these are the packages that do require some of them to be updated. Every package has a dependency on other packages. So if I'm installing package ABC, it might requires a package of XYZ. Just like in Windows, if you are trying to install one package, it might require you to install Java as well, or Flash, or some of those other packages. Similarly, Linux works the same way. When you are installing one package, it does have other dependency, so it has to have those packages updated as well. So that's what it's saying, that it will install 5 packages, new ones, and there are more updates. There are 209 packages of it. So that includes that includes the dependency as well as the updates of the packages. So we will say, is this okay? Yes, it's okay. Go ahead. And yes, if I had put in space -y, it would not have asked me to put in my y, or it would not have waited for me to put y. So I'll hit y as yes. So it's downloading packages. It is going through the update process of 449 packages that it needs to update. This will take quite some time. So what I will do is I will fast forward this, so at least you could view it how it is going through each package update. Once the packages updates are done, then it will do the cleanup and remove any lingering process that's out there. Okay, the system has been updated and it is complete. We did not get any error messages. And by the way, I should have mentioned at the beginning, this make sure your system can go outside, and every time you need to make sure you could just simply ping google.com. It does go to Google, but just to make sure we have the right one. So it is going outside and it is pinging every time you see it's coming back with 64 bytes from this machine. It means it has internet access and it could talk to the server outside. If it cannot, then you definitely have an issue, and network issue, and first check those before you run the yum command, because the yum command is actually going to the CentOS repository to download your packages or update your packages.
Okay, guys, so in this lesson, we are going to cover advanced package management. We have the package in our environment, we installed it, we learned those couple of commands earlier, and one is yum, and the other one is RPM. Now, RPM is a Red Hat package management command. There are other commands that are used in other Linux distribution like apt-get for Ubuntu and many other different flavors. But anyway, our focus is on CentOS and Red Hat, so we will be using RPM and yum command. So what exactly we are going to do in advanced package management? Well, in advanced package management, we will learn how we could install packages. Hey, we could do that through yum command, right? Yeah, of course we could do that. That's the best way to do the installation of the packages. What if you already have the package and you just want to install it? So that part will cover. Then we'll learn we could do the upgrade of those packages, followed by how we could delete those packages. Then we'll see how we could view a package detail, meaning if you have an installed package and you want to know more information about the package, how or when it was installed, what that is package is about, when it was built, what are the configuration files associated with it, and a lot of other information related to the package. Then also identify the source or location information. If you have a file or if you're running a command, let's say you run a command pwd or ls, you want to know which package that command belongs to. So that type of information will cover. So, and last one is the package configuration file. So if you have installed a package, let's call it ABC. So we all know that all the package configuration files are by default in /etc. So once the package is installed, then a configuration files gets created in etc, but then it goes into subdirectories. So etc slash this slash that, that we don't know. So sometimes we even forget. So how can we find out that information about a package if we have done the download installation and now it's about the configuration of that package. So those are the things that we'll cover. To go over one by one, all those things, I'm gonna go ahead and log into our Linux machine. I'm gonna use our putty session to SSH into the Linux machine. So let's go into our Linux machine right here. I have already logged in, and I am logged in as root. And you could also verify by looking at this pound sign. Okay, so the package that we are going to install in this lesson or in this practice is corn shell package. Now, corn shell is a shell which you probably have already know about. It's just like a bash or C shell. So I'm picking this just for practice purposes for just for this lesson. So corn shell is the package that we do not have in the system and we are going to install. Needed to be upgraded, deleted, view its package information, and we'll cover everything that we have listed on this lesson. So let's say if we have a corn shell package already installed in the system. So to check that, you will have to do rpm-qa grep for corn shell. And you'll see we do not have that package installed in our system. So now we have to install the package through two ways. One is that we run yum install the name of the package. The second one is that we download the package through different means. If you do not have internet access, then you could download the package, then install it. But I do have internet access on this machine, and I could verify it by doing ping www. Let's say facebook.com, and you'll see I'll get a response back. See, it means that I am online. So you could also check by running ifconfig command, and you'll see I have an IP 192.168.1.13. You probably have a different IP, depends on which network you are in. Anyway, so I do have a internet access, and I don't need to download a package. So what I could do is simply do yum install ksh corn shell. Anything that is related to corn shell, I could just put it asterisk. So I hit enter, and you will see it did find a package, one package, and the name of the package, and it says X64 package. It doesn't have any dependencies. Good. So I'll go ahead and hit Y. Also, if you notice, the bottom tells you the size of the package, installed size. You could confirm everything before you could go ahead and hit Y. So hit enter, and this is going to download the package first. And then once the package is downloaded, then it will go ahead and install that package, verify to clean it up. So let's give it a few seconds and let it finish. The package installation has been completed and it is successful. Once you see at the bottom it says complete. Now how do we verify it? Hit up arrow key again and you will see you have the package last ran rpm-qa grep for corn shell. Hit enter and
this is the package that was installed during our yum install command. Okay, so now what if you wanted to remove that package? You could simply run the same command yum remove corn shell and hit asterisk and hit enter. This is going to go ahead and remove the package that it just installed. Hit Y, and it is complete. Now run the RPM command again to query your database and the list of packages that installed, and you'll see there is um, nothing installed that matches corn shell. Okay, so that is the first and most preferred way to install and download and install a package. Now, coming back to the same scenario, what if you do not have internet access, or what if you do not have a local repositories? Then what you have to do is you have to you have to know the exact location where the file, how to download a file, and then do RPM command to install the package. But first, let's go to our internet, and I'll go to Google. If you have a different one, different search method, web server that you could use Bing or whichever anyway. So I'll type in, as you can see, I already have typed in before, download corn shell for CentOS 7. So hit enter and go and click on the first link. This will bring you to the packages.org page. Come down and all the way down, and you see where it says the package that ends with .rpm. Just simply right click to it and click on copy link address. Once you did the copy link address, go back to your Linux machine, and now this time type wget and the package exact location of the package and hit enter. Now you're probably thinking, hey, I don't have internet access, then how can I download this package if I don't? Well, the simple way is you could go ahead and download on your machine, on the machine that already has internet connection. You download and then you can FTP over, or whichever way is preferred for you that you can FTP over. It has downloaded. Where did it download? Let's check PWD. It's downloaded in /root. Let's verify it if it is there by doing ls-ltr, hit enter, and you'll see this is the package RPM. Now we have installed this package before using the command yum, but now this time we are going to install this package using the command rpm-hiv and the name of the package. The HIV are the different options. You could use HIV differently, VIH, IVH, whichever the way you prefer. I prefer this way. So go ahead and hit enter. And now it has installed that package. And now you could check by running rpm and QA and grep for corn shell, and you will see the package is there. Right? So that is the way you could install that package. Now, what if you wanted to verify the information about the package? You could do rpm space qi as an information and the name of the package. Copy, right click, hit enter, and you'll see the information about the package. The package name is corn shell, version, release, architecture, install date, group, and a whole bunch of information. Where you get it, what exactly it does, what's the information about. So this is about the information of that specific package that has been installed in your system. Okay, so next step is how can you delete that package using RPM command. Remember we learned how to delete a package using yum remove command. Now let's delete a package using RPM. For that you need to know exactly the name of the package. So name of the package, you have it by running the command rpm-qa. Now run rpm-e as for delete. Specify the entire package name, hit enter, and now it has deleted that package. Verified by doing rpm-qa and grep for corn shell, and you see it has removed that package. Okay, so now this was about removing the package. Now I wanted to cover more things about this package, so I'll go ahead and install it again. This time I'll install it with yum install corn shell asterisk this package.
and it has installed that package. Perfect. Again, verified. Yes, that package is there. Now, I need to list configuration file of this package. How can I list that? So you could do rpm qc and the name of the package. Hit enter, and you'll see the configuration file that you need to modify in case you need to do some configuration of the package. And these are the list of all the configuration file. Remember, I told you the package configuration file are always in etc directory, but then once you are in etc directory, there are thousands of files, thousands of directories. So where do we have to go exactly for that specific package? Well, for that, you have to find out the configuration file. And how do you find out? I just showed you rpm-qc. Now, what if you wanted to find out some information of a command? Let's say if there's a command associated with this package, and the command for that package is, I know offhand, is corn shell. Just hit enter, and that will bring you to a corn shell. Just like a regular command like pwd, ls command, every package has a command associated with it. So let's exit out so we could go back to our bash shell. So this is a command. And what if you want to know which package this command belongs to? For that, you have to run the command rpm-qf and ksh. Oops, sorry, I forgot. First, I need to know the path of that package, that command. So I'll do which ksh. And it's telling me that ksh command, the full path is user bin ksh. Now I could do that command rpm-qf, and I'll put that here. Hit enter, and now it's telling me, hey, this command that you run, this command belongs to this package. Good? Good. Now, you're probably thinking, hey, this is fun. I could find out all the package information for all the commands I have ran, right? So far, whatever the commands that you have learned, you could definitely find out which package it belongs to. For example, my favorite command is, let's say, every time you log in, I wanted to see who is logged in or which directory I'm in. So let's say pwd is the directory, right? That's the command which tells you which directory you are in. So if you wanted to know which package this command belongs to, first what do you need to do? You need to find out the command path. So which pwd. Now you know that this command, the full path for this command is user bin pwd. Now, do rpm-qf/user/bin and pwd, and it is telling you that this command pwd belongs to a package called core utils and then version. If you remove this package, then you cannot run the command pwd. Then which directory you are in, how are you going to find out? You cannot find out. So you would have to reinstall that package again using yum command or going to the link and downloading it. So that's how you actually find out the information about a specific package, a specific configuration of a package, or the package information of a command. Package management is one of the things that everyone would face in their career at least twice a year or 3 times a year when you have to do or install or upgrade the packages. Hopefully this lesson serves its purpose. If you have any question, always send me an email. Hi, so now this is the topic about creating a local repository from your DVD. Now, what is a repository? A repository is something where all your packages are stored, and then you could download and install the package that you wish to. Now, you do need an internet access to go out of the outside repository and download and install the RPM. But what if you do not have internet access? That's what exactly the local repository comes in. So you have a Linux machine, right? Whether it's a virtual or physical machine, doesn't really matter. It goes out to the internet, and then it goes out to a server, which is also most likely a Red Hat server or CentOS server, which has a repositories.
Now, some companies do have those repositories local to their environment, which is called, the product that holds that repository is called satellite server. So that is the repository which holds all your repos or RPM packages. So you could bring them back in solid downloads. Now, what happens if you do not have access to the outside world, or if you do not have a Red Hat satellite server in your environment? Then how are you going to install new programs? Well, in that case, you create a local repository within your server. So this is what we're going to learn in this lesson on creating a local repository. So the command to create, or we will learn in this lesson, it's create repo. That's just one simple command. So how does it work? So let's get into our Linux machine. My virtual machine is powered off. Now I want you to go ahead and create a snapshot. What snapshot does, it just takes a snapshot in case we need to revert back, or if something goes wrong, we could always go back to that snapshot. So click right here, see the snapshot, and click on take, and it by default gives the name snapshot1, but you could give the date or anything that you like that will make you remember. I like to pick date, or sometimes if I'm creating multiple snapshots. So now it has created a snapshot. So in case I mess up during this creating local repository and I need to revert back to my original state, which is right now, then I could always come back to it. So now let's go ahead and power on. Okay, so our machine has been started. So let's go ahead and become root. Okay, so now you are creating a local repository. So what you're going to do is you're going to take all the RPM, all the packages from your DVD or CD-ROM drive, which is a disk which has all your packages. So what you do is you go into these menu devices, optical drives, choose disk, and pick CentOS ISO image. So I have it saved on my desktop, so just choose it and click open. So now this should automatically mount your DVD to your Linux machine. See, right away a pop-up menu came up, and also if you notice, it will also create an icon on your desktop saying this is the disk that has been attached. So now we have it attached. How can we verify it? On the command line, you do df-h, and you will see right here the last row tells you that it is at dev sr0, and it is mounted on run media ifsol CentOS 7. So now if it is not mounted automatically, then you could run a command mount /dev cd-rom and wherever you want it to be mounted. Anyway, since it's already mounted for us, now the next step is, where are you going to put all your packages? So you have to create a directory, right? So the directory I'm gonna pick is, let's go to /cd/ and under slash make a directory. Let's call it local repo. It's just the name. You could pick anything. You could pick Seinfeld, George, Kramer, whatever that you like. So go ahead and hit enter. Do ls-ltr to verify it is there. Yes, the directory is there. Now I want you to copy all the content. So do df-h. So copy all the content of the disk. So do cd/run/media/ifsol. Now if you notice, the name of this ISO image is CentOS space 7 space SS86. Now Linux does not like spaces, so how are we going to put that in my path? So if I just put in CentOS space 7 x86 underscore 64, see, it says no such file or directory. Then how can I make Linux understand that there are spaces? To do that, the best thing that I would tell you to do is do cd run media ifsol, and when you are at this point on the fourth directory subdirectory, then hit tab, and it will automatically pick the ISO image under the ifsol directory. So if you notice, it has backslash backslash, which is telling Linux that there are spaces in it. So go ahead and hit enter. So now you are in that directory. Do ls-ltr and see what's inside of it. You see there are a few directories and files. cd into packages, that's where all the RPMs are. You could do ls-ltr and you will see a bunch of RPMs in there. Okay, so if I wanted to see how many RPMs do I have, I could do ls-ltr pipet wc-l, and it's telling me there are 3,973 packages or RPMs that are coming within that DVD ISO image. Well, that's a lot. So it is kind of like a repository. So what we're gonna do is we're gonna copy all of these packages to our local drive, local folder that we just created, and the folder name is local repo, right? So now before you do that, also make sure that you have enough space in your Linux machine. So how do you find out? First, you are in that directory, right? Packages, run the command du -sh and dot, which asking the Linux machine, give me this disk space of the current location of the directory that I'm in. Hit enter. It's saying 3.7 gig. Now do df-h and make sure your slash directory has that space empty. Yes, we do have 4.4 available, so it's good. So now we could go ahead with the copying every package that we have in this location. The command I would use to copy is copy everything from this directory dot, or you could specify the full path, run media ifsol CentOS packages. So you could do everything asterisk, because you're copying everything under packages to your local repo. Hit enter. Now it is going to copy every single RPM to the local repo directory. This is going to take some time. If you open up another window and then you go to cd to local repo and do ls-l, pipe it to wc-l, you will see the number of files being copied. So right now we have 1480 files that have been copied. We have to go up to 39 and something files to be copied. Okay, all the RPMs have been copied successfully. Very good. So we have to tell Linux, don't go outside. We do have all the packages locally. So how do we define that? So there are files in etc yum.repos.d. These are all the files that tells the Linux to go to these different mirrors. So what we're gonna do is we're gonna remove everything in here. Now again, before you remove that, please make sure you do have a snapshot. If you delete all of these packages and you do not have the snapshot, then you won't be able to go to internet and download the packages through yum commands. Okay, everything is gone. Now go ahead and create a new repo here. Call it local.repo. And add these values. CentOS 7, it's just telling it these are repository for CentOS 7. Name CentOS 7, base URL, this is what matters, So file / local repo. This is the directory that we created in slash. It was always start with 2 slashes, then the third slash with local repo directory. Enabled and 1 to if you want to make it enabled. GPG check 0. These are some of the default values you have to put in to that file. Go ahead and save it. Once that is saved, now run the command create repo and where is my repo? Local repo. You hit enter. Now it's actually what it's doing is it's actually going to that local repo directory and it's saying, hey, I have 3,971 packages. I'm gonna make them available to my local machine as a repository. The create repo had created the database that will be available to our yum command. Now go ahead and create yum clean, run this command yum clean all. This is going to clear out any cache from the old repository. Go ahead and run yum repo list all. Now this should tell me my full list of repositories. There you go. So we have a repo list that has a total package of 3,971. These are the exact same number of RPMs we had, remember? And it telling you the size, the repo ID, the CentOS is the name that we picked in that rpm.d directory file. Now you could test it by running the command yum install. Now what do we want to install? Just for test, type Tomcat. It's gonna go into that repository and check if it has the packages that matches Tomcat. Okay, perfect. It did find that package, and this is basically how you create a local repository. Now the system is not going out on the internet or to your Red Hat satellite. It is actually going to your local repository, which is sitting within your Linux machine.
Hello everyone, and congratulations that you have completed RH124 module, which was section 3. Now, welcome to section 4. In this section, we are going to cover all the advanced topic of Red Hat administration that is covered in RH134. As you already know, you do need RH124 and 134, both combining these classes in order to pass your Red Hat certification. So I'll see you in the next lecture.
Now, since we are on the topic of assigning permission to files and directories and changing groups and ownership, we have to look into access control list as well. Access control list is another layer, or I would say a top layer or additional layer that runs on top of your permissions, which allows you to assign permission per user. So, what is ACL? ACL stands for Access Control List, which provides an additional, more flexible permission mechanism for file systems. It is designed to assist with Unix file permissions. ACL allows you to give permission for any user or group to any disk resources. The use of ACL. What is the purpose? Think of a scenario in which a particular user is not a member of a group created by you. So let's say if you create a user ABC and it's not a member of the group root, but you still want to give some read or write access. How can you do it without making the user a member of the group? And that's where we have access control list, which will help us do it. So let me put it in a very simple words one more time. So let's say if you wanted to allow a file that is created by root and allow that user to read that file. Now, that user is a regular user, not part of the group root, and you want that user to read that file. So of course, the one way to do it is you change the read permission of others, the last 3 bits, so others can read it. But then everyone else could read that. But we only want one user to read that instead of all other users to read it. That is why we only give permission to that particular user using ACL. Hope that clarifies. So basically, ACLs are used to make a flexible permission mechanism in Linux. From Linux man pages, ACLs are used to define more fine-grained discretionary access rights for files and directories. The commands to assign and remove ACL permissions are set FACL and get FACL. So set file ACL, get file ACL. Get file ACL will give you the information about the existing permissions of a file, and set will allow you to set the way you want it to set. Let's look at a few examples. Here are the list of commands for setting up ACLs. To add permission for a user, you have to run a command set file ACL with -n option to modify, U for user, and then you have to separate it with the colons, where user is your username. In my case, it will be iafzol, and then column and the permission that you want to give that user to. And then, of course, the last part is the file name. Which file do you want to give the permission to? Make sure you specify the complete absolute path. To add permission for a group, you could also allow the permissions to a specific group. So again, if you give permission, let's say read permission to the group, the middle 3 bits, then every group in your Linux system can read it. But what if you only want one group to read it? Right? That could be a problem. So then again, access control list comes to the rescue. And to add that group to allow it to read or write that specific file, you have to set with G and group name and the permissions. To allow all files or directories to inherit ACL entries from the directory it is within, meaning cascading, which will be set with -D, M option, and then entry, whatever that you want to put in, and the name of the file or directory. Sorry, of course, the directory, because you want to cascade. A file cannot have a file within itself, so that's why directory would have to have that. To remove a specific entry, you will have to do set FACL with -X to remove it, and then you have to specify the user and the name of the file. This is only for a specific user. Now let's say if you want to remove all the ACL permissions from everyone, then you have to do set FACL with -B option and the name of the file. Couple of things that you need to remember. One is, as you assign the ACL permission to a file or directory, you will see that it will add a plus sign at the end of the permission. So when you run ls-l, the first column which shows you the permissions, it adds the plus sign at the end of it, which shows that it has the ACL assigned to it. The second thing is setting with W permission with ACL does not allow you to remove a file. So you could modify the file, edit the file, but you cannot delete that file. That is something that still the user keeps the permission to itself to delete it. So now let's get into a Linux machine and we'll try a couple of these commands to learn how we could set ACL permissions to a file that is owned by someone else. I am logged in as root, and of course you could always check the root has the pound or hash sign to it, but again, always make sure you are on the right computer, and I am on my right machine. I am in my temp directory and I'm going to create a file. Let's say I'm going to call it Texas, and I'm going to pick just TX as an acronym. Let's make sure it is created and has the right permission. As you could see, it is created, owned by root, and owned by group root. And the owner can read write, the group can only read, and the others can only read. If you do get FACL on the file, you'll see more information. Again, file is this, owner, group, the user permission, group permission, other permission. Now comes to a part where you want to allow everyone, sorry, where you want to allow only ifzol to write to that file. Then ifzol, as you know, counts or considers as other, right? ifzol falls in this category. So if you give right here, if you give that permission as w right here, then what will happen? Everyone else can write to that file. So again, I hope you understand where I'm getting at. So to overcome this problem where only one user can modify that file, then you will assign it as a set facl. So do set facl minus m to modify your permissions. U for user. Who's the user? ifzol. And what permission you want to give? You want to give read and write. And the name of the file would be temp, and the file name is Texas. But before we run it, I just wanted to go in and start, sorry, not this. I want to go in and start a duplicate session, and I want to log in as ifzol. Right now, if I do cd temp and cat Texas, there is nothing in there. By the way, first of all, sorry, not cat, because everyone could read it, so I shouldn't have a problem. But what if I wanted to edit it? So vi text says, it says at the bottom right here, read only. So even if I put in something, hello, or whatever that you want to put, and save it, it will tell me I can't open that file. It's not editable. I do not have permission, so I cannot do it. If when I run this command, get file ACL, sorry, set file ACL with ifzol with read as well and write as well for that file, hit enter. Now to verify it, if it actually has set those permission, you do get facl temp tx. And you will see right now, right here, it says user ifzol has that right to modify it. Now if I do vi Texas now, you see I do not have that same error that I was getting it before. I could just put in anything I want. Hello Texas. Oops. Hello Texas. Save it, and it lets me save it. And when I do cat on Texas, I am able to do that Texas. So that's why these ACL are so important, to assign that specific permission to a specific user. Same thing if you wanted to do that group assignment to the permission, you'd run the same command, but instead of U, you put in G and hit enter. And when you do get facl, you'll see now group ifzol also can modify this file. So if a user is part of my group, they could actually go in and modify that file. Going to number 4, the number 3 one is to actually assign those permissions and cascade down to every file and directory, which is very simple. So I'll jump right into number 4. To remove that specific permissions, I will have to do set file ACL minus X. And what are you taking out? You're taking out the user ifzol's permission. And for that, you have to type the file name. Run get facl, and you'll see that ifzol user is gone. But what if you want to remove everything, not just user, but every permission for every user or every group? Then you will have to run the command set file ACL as minus B option. And now when you do get facl, you'll see it's back to its original state. That's how it works. And when I said you cannot delete, so even though I do have the right permission to write to the file, edit the file, I cannot delete that. So if I do rm Texas, by the way, I have to give the permission back again. This is the permission. Let's verify it again. Yes, I do have permission to read and write to it. So if I try to remove it, it will say operation not permitted. So the reason I'm including that, so I don't want you to waste your time by trying to delete that file and thinking, hey, I do have the right permission, but why can I not delete it? The reason that ACL does not put that in there, so it only gives that right to only the user, just in case by accident that user deletes that file. So that's how the ACL permission works. It's very granular, and it goes down to the user level. And again, one more time, the reason it was built or it was introduced into the Unix or Linux environment is so we could assign permission to the user, not to the every user, but to a specific user. So try it out and try it on different files, try on different directories, see how the directory works as well, how it could change the files if you could log in cd into the directory by giving specific access to a user.
Storage. Okay, what is storage? Storage is, of course, is a hard disk in your computer, right? When you go buy a computer, what do you look for? You look for memory, you look for CPU, and the third thing you look for, how much disk space it has. So there are three types of storage that are attached to your computer. The first one is local storage, which is inside of your computer, which comes pre-built, pre-configured inside of your computer. The second type of storage is SAN. It stands for Storage Area Network. What it does, it attaches to your computer through fiber cable. Fiber cables are now coming in with 8 gig of speed and 16 gigabit of speed. So anything that is attaches to your computer through fiber cable and your fiber cable adapter, that is storage area network. And the third one is NAS, which is network attached storage, which it means anything that you attaches to your computer through NFS or through an IP or through a Cat5 cable, anything that is attached, that is NAS. Also in Windows, Samba is attached through the IP and the folder, and it is shared from a remote computer, and then you mount it to your computer, and that type of attached storage is called NAS. The reason I am including this storage lesson in this training is because many times you will be asked in your interview that what kind of storage you have worked on, or if you know anything about what SAN is or what NAS is. So please be familiar, spend some more time, and Google it if you have to find out what exactly these storages are. Disk partitions. In this lesson, we will learn a couple of commands that are used to show which file system has been partitioned, where is it partitioned to, and what is your local file system disk size. The first command is df, which tells you your disk information, how much disk is used, where is it partitioned to, and the second one tells you how much the disk total size is and how many partitions has been created out of the disk. So let's try both of these disk commands in our Linux environment. The first command I wanted to type is just df, and just by typing df, the first column is tell you where is this file system is coming from, the size used, available, and percentage, and mounted. You could run df-h command and you will get the human readable output, which will be in gigabyte, the percentage, and where is it mounted to. The next command is fdisk, Fdisk without any option is not going to give you anything, so oftentimes it is used with an option -L. So when you type fdisk -L, you will see right here the disk size. Let me do let me make this a little bigger. Okay, so when we type fdisk -L, you will see that the disk is partitioned to /dev/sda, just one partition, and it is 10 gig of space. And right here it is telling you it is mounted on SDA1, which is Linux, and the other one is the first one is the swap and the other one is the actual disk. And it gives you some more information about the disk, what is each size mounted for. If you notice here, the first one, the second one here, it says CentOS swap, and I created a swap for 1 gig, and that's what it's telling me that the first partition, which is right here, is mounted on swap, and the rest is mounted on our dev mapper CentOS root, and which is almost 8.5 gig. So that's why these files, these commands are used for. It is very useful when you want to add a new disk to your system, and then after adding it, you want to initialize it, you want to partition it, and you want to mount it to your mount points.
Adding disk and creating new partition. Now this time we're going to talk about how can we add a new disk to our existing Linux system and then create a partition and of course mount that partition. The purpose behind adding a disk is most of the time you run out of disk space, or sometimes when your computer running multiple application, maybe one partition is required for one application and the other partition is required for another application. So that's why you add a new disks. And of course the commands that we will be using in this lesson are again df and fdisk. Before we get into Linux machine, I want you to open up your Oracle VirtualBox, because that's where we're going to add the virtual disk. Since we do not have a physical server that we're working on, in physical system you would of course have to pull the server out, add a new disk if you have a slot, and then bring the system up. But now since we are working on a virtual environment, it's a lot easier to add disk. Let's go into our VirtualBox. Okay, this is our VirtualBox. Before we could do anything, I want you to, if you are not on this screen, if you are on this screen, I want you to go to snapshot, click right here and create a snapshot, and just name it anything you want that will make you remember. Snapshot before adding disk. Click OK. The reason I'm creating the snapshot is in case you make a mistake while adding a disk, this will make your system unable to boot. So it's always easier to revert back to your original snapshot, so this way you don't lose anything. So now since you have the snapshot, it's done. Now I want you to go to setting and then go to storage, click on controller, and then click on add new disk. Then it will ask you optical disk, which is CD-ROM, or add a new disk. So just click on add a new disk. It will ask you, do you want to choose an existing disk or create a new one? Click on create new disk. Leave the default VDI, VirtualBox disk image, click next. Dynamically allocate it, that is okay, keep it default. And pick a name, any name you like. Let's call it data disk. And I want you to pick 2 gig instead of 8 gig, 2.00 space GB. Click on create. So once you create, you will see you have a new disk. Now click OK. So now it's time to power on your machine. So click on start.
Okay, now I want you to become root. Okay, run df-h command, and you'll see right here, this is the main disk that we have. It is mounted on root. Now run fdisk-l. You could do more because it will come up with the additional information. So when you do more, you'll notice the first disk that we have, that we added while we were building the system the first time, is for 10 gig, which is there, and it is dev sda. And it has two partitions, one for swap and one for the regular Linux VM. The second disk that we added is right here. You notice this disk has 2147 megabyte, which is about 2 gig, and it has units, sectors, and all the information. The other two information, this one is about the partition information about the first disk. This one is telling you the CentOS root partition and the swap partition. So we have to work on this one, which is the new one that we added. Now I want you to run fdisk/dev/sdb, which is the name of the disk. We are using utility fdisks to create a new partition. So you hit enter. When you hit enter, you will notice it will bring up to the fdisk menu or fdisk portal. It will tell you, welcome to the fdisk. Utility changes will remain in memory only until you decide to write them. Be careful before using the write command. Of course, we are careful. If we make a mistake, we could always revert back to our snapshot. So now in this menu, you have different commands, but type help, so you will see the different commands that are available for us. Here are the list of different commands. You could review it one by one. The one that we need to pick is this one, new, because we are creating a new partition. So click N for new. Now, what is this partition type? Is primary or extended? We are primary doing it, we're doing a new disk, so click P, or just hit enter because by default is picking P. Then primary partition number, default 1, pick 1, type 1, or just hit enter. First sector 2048, yes, I want to leave the default 2048. The last sector is 4194303, that is fine, leave it default. If you want to change the size of this partition, you see right here it says size. So let's say if you want to create two partition and each 1 gig, then you could do is plus 1G, and this will create one partition. So we want to use the entire disk, two disk for one partition. That's fine, so hit enter. Now it's done. So it says partition 1 of Linux type Linux and of size 2 gig is set. Now it is not created until we do W. See right here it says write table to disk. And if you remember at the beginning when we ran fdisk, it says it will be in memory until you do W. So we hit W, hit enter, and it is done. Calling optal or to read partition table syncing disk. Done. So now the disk is done. If you run fdisk again on just do -L, and you'll see right here dev sdb1. Automatically when you create one partition, first partition, it assigns the number 1. Now the volume is created. Now we have to assign a file system type. So if you remember, file system types are like a different type of file systems. We have ext2, 3, 4, xfs, ntfs. They're different types of file system. The latest one that we have in Linux is xfs. To make that file system, you have to run command mkfs make file system .xfs. This is the command, and then you have to specify your volume SDB1, which is the boot device, of course, and you hit enter. When you hit enter, you will get all that message with all the details, how the file system created, what are the other information, size, sector, and a whole bunch of stuff. So now it is created. Now what do we do with that? Now we have to mount it to a certain mount point. That's why we're gonna make a use out of it, right? So I want you to create a directory mkdir under root and call it data. Hit enter. Now this is created. So if you do ls-l under slash, you will see it is created right here. Now we're gonna mount that to our partition. So the command would be mount
slash dev slash sdb1, which is our volume, space data. So we are mounting that partition that we created to our file system, to our directory that we just created slash data. Hit enter. It is mounted. How do we verify? Now you run df-h and you will see right here at the bottom, it created our partition. There you go. See? So now we could write to it whatever that we wanted to do. Now, every time your system reboots, it will not mount this. So how can you make it enable that it will get mounted at a system reboot? Is you have to add an entry vi into fstab file. Fstab has all the information about your partitions. You hit enter, come down all the way to the bottom, hit O in news to add a new line, then type slash dev sdb1. Remember, this is the volume, right? We created a new partition. Tab, where are we mounting it to? We're mounting it to slash data, right? Yes. Then tab. The next one column is what type of file system is it? It's XFS file system. Tab. Then the rest, leave that default. And then tab 0, tab 0. Those two zeros that I added mean something. These are the options that it would run file system check when the system boots or not. So you could look into it in more detail by running man on fstab command. Just type man fstab or just search it online and you'll find the meaning of every field in it. Make sure you don't make mistake. If you make a mistake, you will have a problem booting your system. Then you would have to revert back to your snapshot. That's why I asked you to create a snapshot. Again, read it again and make sure you are typing it correctly. So now it's done. Hit escape, right quit, and enter. So now when I do init 6, you'll see the system will boot. And when it boots up, it will have that slash data mounted. Okay, when you log in, open up a terminal and now df-h, and you will see right here dev sdb1 is automatically mounted. And the reason it is mounted is because we have that added in our slash fs tab file. To unmount it, if you want to unmount, for example, just become root and hit enter your password and type umount slash data, the mount point, hit enter, and you will see it is gone. See, it's no longer there. If you want to mount back in, mount it again, you have to run mount the whole command, or you could simply type mount -a. What this will do is it will go into etcfs tab and see what are the mounts, what are the file partition that I have to mount, and it will mount it, all of them. You see at the bottom, it mounted back again. So anyway, you could leave that data in, you could leave this disk if you want to, or you could remove it, it's up to you. But if you had made a mistake and your system is not coming up, you could always go back to your Oracle VirtualBox and then you could stop your machine and revert back.
If you want to learn more about Linux, check out my best-selling course on Linux at udemy.com, or you could go straight to my website utclsolutions.com and you will find the exact same course there.